some forest fire is also playing a role to increase this global mean temperature. In addition to this evidence, there is another evidence that is a global mean sea level that is also rising at a rate of about 3.3 millimeter per year. So you can see it is this is the data from almost 1990 to 2020, and there is a sharp increase in the long term in the mean sea level. So, is there only these two factors are increasing with the time, or there are some other things which are increasing with the time? So, as we can see from this figure, as what the population is increasing, CO2 emission is also increasing, NOx emission is increasing because of fertilizer consumption is increasing, and because of the fertilizer consumption, total anthropogenic nitrogen is also increasing. So, these all factors are increasing with the time in parallel way. About the health impact of aerosol particle, there is a very strong evidence how it can influence even before the birth. So this is the some group from the Belgium. They performed this ambient black carbon studies on pregnant women, and they found the black carbon particles can reach even the fetal side of human placenta. Most important results they propose is that the number of the black carbon particle in human placenta was more in case of women who was exposed with more combustion derived these fumes. So this indicates that air pollution can even influence the before the birth. So we have a national ambient air quality standard in India, especially for two kind of particle. One is a PM10 having a diameter less than 10 micrometer, and another is a PM2.5 that has a diameter less than 2.5 micrometer. The annual concentration for the industrial and the ecologically sensitive area is a 60 microgram per cubic meter from PM10, and for PM2.5 it is a 40 microgram per cubic meter. It should not the level at any place should not exceed these values. However, as studies we performed a decade ago in two cities of eastern central India, Raipur and Durg, we found that the concentration level of PM2.5 and both and even PM10 both is several times higher as compared to standard values, which indicate the high level of risk over this region. So, if there is any other evidence for increasing fossil fuel and biomass burning in India, as we say, these two sources are very important for enhancing the level of particulate matter in the atmosphere. So, as you see, with the time, two-wheelers, cars, and the buses, goods vehicle, everything is increasing. Based on some studies performed, we can see this study from Wang et al. 2016, published in Environmental Science and Technology. And they did emission inventory for the black carbon emission in India, and they found from the 1960 to almost till date, and about 2012 like that, and they found it is there is sharp increase in black carbon emission. So this is India map of India, where you can see the how many coal-fired capacity power plant is existed. That play an important role, for emission of this aerosol particle. aromatic hydrocarbon, and azelaic acid is the photooxidation product of unsaturated fatty acid. So the ratios can give you something understanding about which precursor compound is atmosphere. So here also we found two kind of values for the less biomass burning period or no biomass burning period. The ratios were high, which indicate the more contribution of aromatic hydrocarbons or less contribution of unsaturated fatty acid. But during the biomass burning period, which is highlighted in a red shade color, ratios were low, which indicate that this unsaturated fatty acid contribution to the atmosphere during the biomass burning period was high. So finally, a summary of my talk is that we found the predominance of oxalic acid as among the major organic compounds in PM2.5 samples at Ambikapur during the sampling period. Regarding the temporal trend, we found the peak concentration of the major compound during April month when biomass burning episode happened in eastern central India. This biomass burning episode was further confirmed by the MODIS fire images provided by the NASA satellites, and a significant positive correlation of the biomass burning tracer leoglucosan with these compounds indicates biomass burning as their main sources in the atmosphere. The diagnostic ratio analysis indicated that the photochemically processed aerosols are less when there is a more biomass burning episode, and it is more when there is a less biomass burning episode, and a significant atmospheric processing of unsaturated fatty acid during the biomass burning period. So this biomass burning and atmospheric processing increase, especially the abundance of this compound in eastern central India. And as we detected very high level of PM2.5 level, even the high level of carbonaceous species or individual organic compounds in the atmosphere of eastern central India, it can not only influence the local regional climate, but it can also influence the climate of the outflow regions. So thank you very much.
Well, thank you, Dhananjay ji. We are very much thankful to Dr. Dhananjay Kumar Deshmukh sir for enlightening and entertaining presentation on aerosol particles and its effects on climate directly or indirectly. Sir has highlighted the various factors of air pollution too, and we are very much thankful to him for very nice presentation. Thank you, sir.
Thank you very much.
Now, let us move to the second technical talk. May I know that Dr. Ankush Vij sir has joined or not?
Yes, sir, I have joined.
You have joined. Okay, okay. Welcome, sir. We are very much pleased to have Dr. Ankush Vij with us. Dr. Ankush Vij is presently working as a senior associate professor of physics in University of Petroleum and Energy Studies, Dehradun, Uttarakhand. He has done his PhD from Kurukshetra University, New Delhi, and postdoctoral research from South Korea. His research interest includes synthesis, optical and luminescence properties of wide bandgap semiconductors. He has previously worked at Amity University, Haryana, and NIT Hamirpur. He has been a part of several national and international funded projects. He has supervised several projects at PhD and master's level. He has also been a recipient of many prestigious awards. I invite him for his keynote speech. Welcome, Dr. Ankush ji. Please. Thank you.
Thank you, sir. Am I audible, sir?
Yeah. Yes, yeah. You can please continue.
Yeah, sure. Thank you, sir. So let me first share my screen. Sir, is it visible?
Yeah, visible. It's visible.
Okay, and please confirm the slides are moving. I'm changing the slides.
Yes.
It's moving?
Yes,
okay.
It's moving. It's moving.
Yeah, that's good.
Perfect. Perfectly all right.
Okay, sir. So thank you, organizers. Thank you, Dr. Vikas Dubey, for inviting me for this presentation. So my presentation will be on the topic synthesis and luminescence studies of some sulfide and oxide-based phosphors. I'm working in Department of Physics, University of Petroleum and Energy Studies, Dehradun, Uttarakhand. So the content of my presentation comprises of a bit of introduction of luminescence and phosphors, and some of the techniques which I have used in my studies, experimental luminescence techniques, especially photoluminescence and thermoluminescence. And then I will be briefly touching upon what is the role of dopants in wide bandgap phosphors or semiconductors. And then I will be presenting some of my experimental results which we have done in our laboratory. I have chosen two compounds, strontium sulfide and magnesium borate based phosphors. And then finally I will be concluding. Just briefly introducing luminescence. It's basically a process in which a substance absorbs energy in some form or other, and the absorbed energy might be re-emitted in the form of radiation which falls in visible or near visible region, right? So any material which emits in visible region or near visible region, it is called a phosphor material. So phosphor basically is a class of materials, right, which emits in visible or near visible range. And depending upon the this mode of excitation, we have number of forms of luminescence. For example, photoluminescence, chemiluminescence, electro, mechano, bio, thermo, right? So, and by any mean we can give energy to the system, but eventually we get emission in the visible or near visible region, right? So we have plenty of applications based on this luminescence. For example, we have fluorescent bulbs, solid state lighting for white light, long afterglow, storage phosphors, radiation dosimetry, which has further been subdivided into many kinds of dosimetry. For example, environmental dosimetry, medical dosimetry, space dosimetry, etc. Then it is also used extensively in medical imaging, especially IR emitting materials. Nowadays they are finding preferences in optical imaging. Then paints, then upconversion, whereby we excite the system with low energy and get luminescence in higher energy side. Then we use of luminescences in CRTs, scintillators.
Excuse me, Dr. Ankushji, your slides are not moving. You are we are on the first slide now.
Oh no, I am on the second slide.
Yeah. Okay. So please, yeah.
Is it moving now?
Yeah. Fine.
Okay. Earlier I have done full screen mode. I think then it was not moving from your side. You could not see that. Okay. So it has plenty of applications, as I told, in many of the areas. So I will be briefly discussing this photoluminescence technique, in which we study two kinds of things, PL emission and PL excitation. So emission spectrum is obtained by plotting wavelength versus intensity, as all we know, and PL excitation, we have relationship obtained by observing changes in the emitted light intensity at a set emission wavelength while varying the excitation energy. So in this typical experiment, we have a light source, which is generally a broad source, which gives you many kind of wavelengths, and then we have excitation monochromator, which uses one wavelength, and then that lambda excitation, suitable excitation wavelength for particular material, is made to fall on the sample, and the sample upon de-excitation, it gives emission, right? And then one by one, again, this emission is sent to emission monochromator, and one by one it can be detected by the detector. So I have shown here some representative excitation and PL spectra for strontium sulfide bismuth doped material. So you can see here this excitation spectra has been recorded at a fixed emission wavelength of 494. So we have fixed this lambda at 494 and then scanned this light source, and whereby we are getting these two excitation bands. And then at these two excitation bands, at around 350 nanometer and around this 440 nanometer, again we did this photoluminescence emission study, and you can see that at both the excitation channels we are getting luminescence at the same, almost same wavelength of 494 nanometer. So we can see that, but however, the efficiency at 440 nanometer excitation is quite high than the excitation at 350 nanometer. So probably this 414 nanometer excitation is due to the excitation of bismuth levels directly, and this 350 nanometer correspond to the band-to-band excitation. And so what's happening is band-to-band excitation energy is also effectively transferred to the bismuth levels when we excite the system at 350 nanometers. So at both these excitation wavelengths, we are getting emission in at the same wavelength. So therefore, it is extremely important whenever we perform such experiments to explore the full excitation spectrum at each excitation wavelength. We should get photoluminescence emission checked. And then the second technique which we have used is thermoluminescence technique. Basically, in this technique, a phosphor is excited with some radiations for a desired period of time, and after which exciting light is removed. So basically, any material which have trapping states only gives a TL signal, right? So during irradiation, we are filling those traps, and while we increase the temperature, we are detrapping those, and they can give the TL signal, which is recorded. So generally in this typical experiment, we have sample which is placed over this planchet, which is connected with some heater, and we can increase the temperature over here. And this sample must be pre-irradiated, as I told, with any kind of radiation, maybe gamma, UV, alpha particles, X-rays, electron, whatever energy, right? And when we heat this sample can give some signal upon detrapping the charge carriers, and which is ultimately recorded by the detector, and then we can get this as signal. So that material is heated at constant rate, and light output is measured as a function of temperature. And typically we get this kind of curve, which is the intensity, TL intensity versus temperature. So this is called TL glow curve, right? In PL we were getting wavelengths as well spectra, but here is a TL glow curve. Simultaneously we can put some other detector, and we can also measure it as a TL spectra. So TL spectra means it is with respect to wavelength. Now, since we are working mostly in wide bandgap materials which have bandgap well beyond the visible region, so therefore the role of activators becomes very, very important. So the PL emission of the same host material, it can be tuned differently by changing the activator. So usually this activator is introduced into the lattice of the host material in ppm, that is parts per million levels, by heat treatment. And this dopant level, it forms discrete energy levels within the host material, right? And which can give rise to some radiative centers, a recombination of carriers, where this recombination of carriers can take place, right? So such centers are called luminescent centers. So these activators, they introduce luminescent centers, which otherwise the host material being bandgap cannot give any luminescence. And sometimes more than one dopants, they are used in many materials. They are called co-activators. For example, we have YVO4, europium samarium dope, cerium samarium dope, MgO. So the properties of such dope system, they offer us the energy transfer mechanisms we can study, and they exhibit some very exciting results. So while choosing these combinations, we have certain factors which should be kept in mind: the size, valency, crystal structure, electronegativity of the dopant. They all should be at least comparable, and it will affect its performance in each host. And also we should note that the dopant should be incorporated into the lattice without creating too many defects, because sometimes these defects can act as killing centers or the non-radiant relaxation, and they will reduce the luminescence efficiency. And another important thing is the charge of an incorporated ion must be accounted for, which is generally done by adding some suitable flux during synthesis. So whatever dopant we are replacing with, that may have a different valency than what it is replacing. So that charge neutrality has to be kept in mind. So now I'll be highlighting few applications of PL and TL, which we have been doing in our work. So we have been working on kind of materials for fluorescent lamps. In fluorescent lamps, generally what happens, mercury discharge lamps, they emit at 254 nanometer, right? And in order to convert this into visible light, such lamps they are coated with suitable phosphor, which can absorb 254 nanometer, and which can in turn give you the visible region light, right? So these phosphor materials must be an efficient absorber of 254 nanometer, and in return emit visible light efficiently. So therefore, these luminescent materials, they are extensively used in fluorescent lamps. But however, nowadays these fluorescent lamps, they are obsolete because of the saturation in their efficiency. Their efficiency cannot be made higher than 25% because of this equation that we all know, right? So therefore, now the scientific community has switched to a very important concept, solid state lighting. The solid state lighting refers to a type of lighting that uses light emitting diodes as a source of illumination rather than electrical filaments to produce white light. And what are the advantages we are having? They're highly energy efficient, they have long life, and they're cost effective in comparison to the other fluorescent or incandescent bulbs. So we are actually looking for phosphor materials which emit in white light. So generally, how to produce this white light? Blue LEDs are used, and they are combined with some yellow kind of phosphors, right? So blue can be absorbed by the phosphors and they can emit U. So part of blue and yellow combined to give the white light. But the disadvantage with this kind of white light is that if we compare it with the sunlight white light, so you can see this is a kind of diffuse sunlight spectrum which is peaking at 485 nanometer and spanning almost in the entire visible region. But when we compare it with there's a blue and yellow kind of combination which I just talked before, you can see here there's a blue and there's yellow part. It's almost a white light, but its CRI is almost 75. But the exact diffuse sunlight, the CRI has 100. So it has poor CRI, this method. So generally conventional approach then can be use of assorted LEDs. We can use blue, green, red, 3 LEDs, but controlling the output of LEDs and combining their output is very, very tedious job. So it is also not well worked. So the alternate approach is we can go for a single material which upon excitation with either UV or blue can give us the direct white light without involving too many phosphor system. So a direct white phosphor is a single material that emits high quality white light. So therefore near UV or UV LED plus RGB phosphors. So therefore the ultimate goal is to develop suitable direct white phosphors which has good CRI as well as other parameters. And the other application which we are working in is the radiation dosimetry. So radiation dosimetry is the direct application of thermoluminescence. So dosimetry in its original sense is the measurement of absorbed dose delivered by ionizing radiation. And in terms of health physics, if we see, and medical physics, it is the calculation and assessment of the radiation dose received by the human body. And it is nowadays becoming very, very important because it is very extensively used nowadays in cancer treatment and the diagnostic purposes, right? And this radiation dosimetry has its application in personal, medical, environmental, retrospective, space dosimetry. And all these kinds of dosimetry requires different set of materials because the dose range is entirely different. And there is not a single material still exists which can satisfy all these ranges differently. So we have to plan for which kind of dosimetry we have been working in, because if we are working in personal dosimetry, the dose range is 10 to the minus 5 to 0.5 gray. And when we are going to high dose dosimetry or a nuclear reactor, then that the dose is very, very high. So therefore, people are working in different class of materials which work in these different regimes of doses. And these are 6 general set of properties which must be satisfied for any material in order to we call it as a dosimetric material. So apart from this dosimetry kind of thing, TL is also a very excellent tool for characterizing the defect states, especially the trapping states, long-lived states. So now I will be presenting some of my results on strontium sulfide based phosphors or nanophosphors. Strontium sulfide is basically a 2,6 wide band gap semiconductor, and the band gap is in its undoped form is 4.2 electron volt with structure FCC, and it belongs to alkaline earth sulfide family, and it's very excellent material for many of the optoelectronic applications. And since its band gap is very high, so it acts as a phosphor only when it is doped suitably with the dopant elements. So we have synthesized strontium sulfide based material using solid state diffusion method, whereby we reduce the sulfate into sulfides. At the same time, we also incorporate the dopants into this lattice, right? So we have tried several dopants in the system. We have tried cerium, samarium, manganese, bismuth. So I'm presenting some cerium and samarium results. So the material synthesized using this method, strontium sulfide samarium, strontium sulfide cerium samarium. You can see here XRD, which tells us the both are single phase FCC structures. And then we perform X-ray absorption spectroscopy, which is a very sensitive tool for studying the local electronic structure of the material. And why it is important? Because the dopant used in phosphorus is in so small quantity, it cannot be directly measured by some of the bulk techniques like XRD or this and that, right? So, and also the important thing is that what is the balance state, charge state of the dopant within the material which governs the luminescence, that needs to be studied in detail. So therefore, the element-specific X-ray absorption spectroscopy technique using synchrotron radiation is a powerful technique to probe the presence of dopants and local electronic structure of the material. So generally in this technique, what happened, we choose the edge energy, means for example, strontium sulfide, cerium, samarium, I have a system, I can probe the strontium ion by choosing the X-ray energy of strontium K edge or L edge. Similarly for sulfur K edge or L edge, or we can choose for the cerium or samarium either K, L, M edge and probe accordingly. So there are two methods of detecting, doing these EXAFS measurements. One is in the electron yield mode and another one is the total fluorescence mode. So this electron yield mode is very, very surface sensitive. So sometimes we see that the PL spectra, we have some interchange of balance states at the surface, but beneath the surface it is okay. So in that kind of experience, it is very, very important tool to study those things. So generally this EXAFS spectra, it can be distinguished in two parts: the near edge study and one is the extended edge study. So this ZANES, X-ray absorption near edge spectroscopy, and EXAFS is the extended X-ray absorption fine structure spectroscopy. So both these different regions, they give us the different information. For example, EXAFS, it is more it gives us quantitative calculation of bond distances, coordination number, etc. On the other hand, the ZANES or EXAFS, the same things, they are more of qualitative in nature, and they tells us about the various coordination chemistry or various hybridization of orbitals in the band structure, the density of available electronic states, and very important, the balance states. They can be elucidated from this ZANES and EXAFS structure. So in the present study, we have done some EXAFS or ZANES experiment in Pohang light source, South Korea, and also in the Taiwan light source, Taiwan. So this is an EXAFS study. So in strontium sulfide samarium dope systems, we can see that we have done samarium M edges study. This M5 M4 edge. This one is a 0.1 mole percent. This is a 0.5 mole percent. This is 1 mole percent. And in order to study this, we also simulated samarium 2+ and samarium 3+, because these M5 M4 edges, they are quite sensitive to the charge state. So we have done simulations on samarium 2+ and samarium 3+. So it clearly tells us, we can see that our experimental curves, they quite resemble with the samarium 3+ structures. So it tells us that predominantly samarium enters into strontium sulfide as samarium 3+. However, at 1 mole percent, we can see that we have this feature A, and this A feature corresponds to samarium 2+. You can see this here. So when we are increasing the concentration, some of samarium 2+ is also started incorporating in addition to samarium 3+. But as I told you, these all measurements, they were done in TEY mode. So then we decided to also to take this 1 mole percent in TFY mode, because then when we perform the same sample in TFY mode, you can see this A feature is reduced drastically. So therefore, we can confer that this samarium 2+ was present only at the surface. When we did the in-depth studies using TFY mode, the samarium 2+ intensity reduced drastically. So predominantly, we can conclude from this study that samarium is present in as samarium 3+ in strontium sulfide. And then we also performed for cerium samarium co-doped system for both cerium and samarium. So again, we can see this black one, the samarium one, and it is again matching with the samarium 3+ system. And for cerium, this system, the blue one is the experimental curve, and this red one is again simulated curve, and which again shows that cerium is also sitting predominantly in 3+ charge state. So we can say here that both cerium and samarium, they are in 3+ charge state. And some of the samarium at the surface, very minor fraction is samarium 2+, and that we anticipate while doing this experiment, X-ray, while X-ray falling on the samples, that may convert some of the samarium 3+ into samarium 2+. And when we performed its photoluminescence spectroscopy at various excitation wavelengths, so you can see that at 430, when we excite this strontium sulfide cerium samarium co-doped sample at 430 nanometer, this red one, so we get emission only due to cerium levels. There is no involvement of samarium levels, you can see. However, it is a doped system, right? So this cerium emission corresponds to D2F emission, which I have described here. D is very sensitive to crystal field, and it breaks up into 2 EG and 2 TTG, this orbitals, and the 4F is sensitive to spin orbit coupling, and it breaks into F7 by 2, F5 by 2, right? So the allowed transitions, there are 2 allowed transitions possible, to which gives you one main peak at around 490 and the other hump at 534, 535 is due to these 2 transitions. Now, when we excited the same system with this blue one, 335 nanometer, the same system, same material. So you can see here drastic improvement. There is no cerium related emission or very minor cerium related emission, but predominantly it is giving only samarium 3+ emission, right? So same material at 430 nanometer, it is given only emission of cerium. At 335 nanometer, it is showing emission only due to samarium. But we also explored another excitation wavelength, which we have experimentally checked by using excitation spectroscopy also. So there was small hump in 393. So we also explored 393 nanometer excitation wavelength. So when we excited the system with this 393 nanometer, we observed the emission both from cerium 3+ and samarium 3+. You can see there the broad peak due to cerium 3+ and also simultaneously these intra-4F emissions. These samarium 3+, it shows very sharp intra-4F emissions, right? So it's a combination of that. So basically what it is doing, it is improving the CRI also, because in cerium emission, the intensity falls sharply beyond 600 nanometer. But in this cerium samarium at 393, you can see the intensity also increases due to the samarium 3+ emission in the lower wavelength side. So it is improving its CRI. Similarly, we also perform the luminescence study of this system using ion beam at IUAC New Delhi, and it was found that they were showing very high scintillating properties. And again, their scintillating properties, they belong to only cerium 3+ emission. And then we also try to optimize these emission by partially substituting the cation strontium 2+ with calcium 2+ and barium 2+ and their combination. So we substituted the cerium is 5%, 5 mole percent, and we chose this strontium. The SCBS means strontium calcium barium sulfide, where the whole base material is strontium sulfide, but partially we replace strontium with calcium and barium, and one we choose with strontium calcium sulfide, and SBS is strontium barium sulfide, and ASAR is pure strontium sulfide, and all these samples are doped with the cerium. So because all these materials, they show the similar lattice structures, though they are quite immiscible with each other, so there is no much change in the XRD pattern. So there's a single phase material, and in all materials we performed again this X-ray absorption spectroscopy, and the cerium doesn't change its balance state, all the cerium 3+ state. And no, but here we can see that the intensity of strontium sulfide cerium, and if we can see this, the green one, the strontium calcium barium sulfide, it's almost 2.5 times higher, right? So we have just replaced the cations, some of partially with the 10% barium and calcium, and we have seen that its efficiency can be improved by almost 2.5 times. And then also we performed the thermoluminescence of these UV exposed samples, and we found the TL peak, however at slightly lower temperature, so it is not suitable for although dosimetry, but then we use this TL as a characterization technique in order to elucidate or quantify the defect states existing in this material. So we use this glow curve deconvolution method, and we see that 3 kinds of defects we have shown here are possible, which are long-lived defects, which can only be emptied with the thermal energy. And the first peak, second peak, third peak, they have the activation energy we calculated 0.75 electron volt, 0.96, 0.67. So all these results indicate that for UV, the strontium sulfide cerium, it is not suitable for dosimetry. And then we also perform the same experiments by changing the UV to the cobalt 60 gamma and heavy ion irradiation. So we can see that the same material is showing a different TL behavior for all these irradiations, UV, gamma, and SHI. So we can see here with gamma, we get 2 major peaks, but however with SHI, the second peak diminishes a lot, and become broader, and the first peak remains there with increase in its intensity. Right. So we have done detailed calculations in paper published in Journal of Fluorizing Compounds. Now I'll be presenting some of our latest recent findings which we've done in the magnesium borate based phosphorus. My PhD scholar is working on this problem right now. So magnesium borate, basically we see that it has various chemical compositions like Mg2B2O5, Mgb4O7, Mg3B2O6, and till now the luminescence scientists, they have been mainly working on Mgb4O7, and there's a plenty of literature available on this material. But however, when we did the literature review, Mg2B2O5 system was found to have a range of applications in anti-wear, anti-corrosion, scintillator, discharge lamp, reducing friction additives, turbines. Means it's a mechanically highly stable system, and it's used extensively in mechanical kind of properties. Right. But however, the luminescence in this system was not explored comprehensively, unlike Mgb4O7. So we tried to synthesize this sample in our lab and try to investigate its luminescence properties. So generally this Mg2B2O5 properties, this crystal structure, it is of two kinds, either monoclinic or triclinic. And from the literature survey, we have found that it's tedious to get a single phase out of it. There is some mixture of monoclinic or triclinic. But we have optimized in our lab using combustion synthesis, that whereby we used these precursors of magnesium nitrate, boric acid, and urea, and we optimized the heat treatment. We performed this combustion synthesis at 600 degrees centigrade, and finally the powder form, it was just heated at 400 degrees centigrade for 30 minutes, and the result was surprising. We get a single phase triclinic structure of Mg2B2O5, right, which we also identified using ritual refinement. And crystalline size using Williamson-Hall plot was calculated to be 49 nanometer. And whatever synthesis condition we have set out here, they were cross-checked with the thermogravimetric analysis also, and it also clearly tells that whatever synthesis parameter we have taken, they were very, very appropriate, because we have chosen the temperature 600 degrees centigrade, and you can see that after 600 degrees centigrade, the weight percent loss is very, very minimal. The maximum weight percent loss is there till 300 degree, and then again it's decreasing, but after 600 is fairly saturated. And we also performed this TEM studies and SAD studies to further confirm electron deflection also, and all these studies tell us that it is single phase triclinic structure. And then we performed diffuse reflectance spectroscopy in order to calculate the band gap, and we used Kubelka-Munk function to calculate this band gap, and which comes out to be 5.23 electron volt. But however, there were some confusions based on literature review on its band gap. Some were reporting its direct band gap, some were reporting its indirect band gap. Then we collaborated with some DFT group, and we performed its DFT calculations, and based on some GG approximation and other parameters, hybrid parameters, and its band gap was around 5.10 electron volt, which was found in good agreement with the experimental result. The experimental result was 5.32. So generally, these DFT calculations, they slightly estimate band gap on the lower side, but fairly well. And when we perform its PL spectra, so since this was undoped system, so predominantly we have done its PL at 325 nanometer helium cadmium laser, and it emits almost peaking at spanning from 500 to 600. So broad emission it shows, although it is far away from white light. So all this emission is probably due to, based on the complex kind of defects, either it may have some oxygen vacancies or some other related defects, cationic defects. And then we have performed its TL studies using UV 254 nanometer, and also we have done using this 365 UV also and gamma also. And we have shown that in this system there exist 4 kinds of trapping defects, and we have qualitatively and quantitatively both studied their structures. And then we doped this Mg2B2O5 with the europium 1%, 3%, and 5%. So we can see that up to 1%, again, this is a single phase triclinic structures, but however, the preferred orientation got drastically changed in 3% and 5%. You can see that this the peak at around 32 degree, it is now started dominating at 3%, 5%. Up to 1%, it is as good as Mg2 or B2O5, right? So while again we checked with the TEM, HRTEM and SAD studies, and we found it triclinic structure. And then we performed again that Zane's X-ray absorption spectroscopy at europium M edges, and from where we concluded that europium is in europium 3+ state. So if europium is europium 3+ state, we were anticipating its intra-4F transitions in photoluminescence, and which we also got, like here. So this europium 1%, 3%, 5%, we got these intra-4F sharp transitions, which we have shown here from the various states of intra-4F levels of cerium europium 3+. So these are some qualitative conclusions that we have drawn. Then we also checked the TL of europium doped systems, and what we have finally, I would like to conclude that europium 3 system, you can see that europium 3 means 3%, europium 1% and europium 5%, they have a very complex TL kind of peak. But at the europium 3+, we have been able to optimize this kind of fairly single glow curve at a high temperature, and which is mandatory condition for any TL dosimeter. So this was the first kind of its study based on Mg2 B2O5 system, whereby we have shown that this material is also equally important for the PL and the TL point of view, in addition to Mg BFO 07. And still this study we are doing with other kind of dopants also. So with this now, I think that we are running short of time, so I would like to conclude. We have discussed the luminescence and luminescence based experimental techniques, and we have discussed the role of dopants in wideband gap phosphors and some experimental studies based on the synthesis and luminescence in strontium sulfide and Mg2 B2O5 system I have discussed. Thank you, sir. Thank you for kind attention.
Okay, well, we are very much thankful to Dr. Ankush Vij for brainstorming session on synthesis and luminescence studies of some sulfide and oxide-based phosphorus, in which he has covered fluorescent lamps, SRS-based phosphorus, different synthesis methods, X-ray absorption spectrography, and the role of dopants very nicely. Well, thank you very much, sir, for your nice.
Thank you.
Thank you.
Thank you very much, sir. Thank you, organizers.
Yeah. Now, thank you, Dr. Vikas Dubey and his team for.
Thank you.
Yes.
Thank you very much to you, sir.
Sir. Thank you very much to organizing committee, management, and principal, sir, for providing me the opportunity to join international conference as session chair. Thanks a lot. Over to you. Thank you.
Thank you so much, Dr. Mukesh Thakur, for doing the honors. Sir has an urgent work, because of which he will not be a part of this conference further, but sir's inspiration and achievement will keep us inspiring. Thank you so much, sir, for being a part. Let me introduce you to the next speaker for today, but before that I would just like to confirm, has Dr. Subrat Das joined?
Yeah.
Sir, can I have your confirmation? Okay, thank you, sir. So our next speaker is Dr. Subrat Das. Let me introduce the person himself. Sir is a distinguished and young material scientist in India. He completed his master's in applied physics from presently known as IIEST Shibpur, West Bengal. He has received his PhD from Indian School of Mines, Dhanbad. So that is a very renowned person itself. Presently, it is known as IIT ISM Dhanbad in the year 2010. And the topic was stimulated luminescence of transportation metal ion doped alkaline earth sulfate. Sir, please wait. Let me finish your introduction.
Okay, okay. Sorry.
Let the audience know who is here to inspire them. Sorry to interrupt you. Just a second, sir.
Okay.
Sir has joined Chemical Engineering Department of National Taiwan University, where he was associated with Optoelectronic Research Group of Professor Chung Hisin Lu. Sir is selected for National Science Council postdoctoral fellowship in Taiwan. Sir has independent academic career as a senior scientist at CSIR National Institute of Interdisciplinary Science and Technology, Thiruvananthapuram. Sir is also appointed as Assistant Professor in Physical Science, ACSIR, India. Sir has experience and research interest in the following field, that is down-converted phosphorus for lighting and display application, up-converted nanophosphorus for sensors and imaging application, persistent afterglow phosphorus for energy-saving display and night vision applications. Sir has research proposal of development of single white light emitting phosphorus and was selected for Early Career Research Award program, which was funded by Science and Engineering Research Board of India. In 19th, Sir has presented research proposal on nanophosphorus for flexible lighting application, and which was selected for, he was also selected for prestigious Indo-French Center for the Promotion of Advanced Research for funding. So we are honored to have you with us, sir. Now the platform is all yours. Please.
Many thank you, madam, for these kind words. So I will try my best to elaborate my research within the short period, so that I can gather some research interest from the audience, particularly from the students' point of view. So let me share my slides. Is that visible in the full screen mode?
Yes, sir, it is visible. Can you please go on slide share so audience can have a better understanding?
This is full screen mode is not visible, madam.
Sir, screen is visible. Slide share is not there.
Oh boy,
At the top corner, there is cup shift.
Okay.
Sir, please present your screen.
I am sharing my entire screen. Okay, understand.
Okay. Yeah, it is now, sir, in presenting. Thank you.
Is that visible now?
Yes, sir.
Yeah, thank you. Good morning to all. It's an honor to present this kind of international conclave. So let me introduce myself first. As Madam told, I will not elaborate. That myself is Dr. Subrata Das, working on optical materials. I am a researcher from CSIR NIST, which is located at the bottom corner of our beautiful country and surrounded by very beautiful naturistic sceneries. As you know that Kerala is one of the cultural hubs in India, and we are located at the heart of that cultural hub at the Thiruvananthapuram. We are among the 37 CSIR laboratories in India, located in the various states and provinces, which have a headquarter at Ghaziabad, Delhi. So it is not mandatory to introduce you what is phosphor, but let me introduce a few glimpses because my later lecture all will be on the topic of phosphorus only. So this actually, as my previous colleague during his presentation elaborated, so I will not go into the details. Phosphor actually it emits light when it is under the irradiation of on the higher energy in terms of whether it is photon, whether it is electron, but output always will be in the form of photonic energy. Okay, if the excitation by means of photons can be done, then it is called the photolumination spectra. And under the daylight, as you can see, these are mainly looking in the white or gray, white or some gloomy coloristic format. But when you put in these phosphor in the UV LEDs or higher energetic light sources, then it will show its characteristic luminations, which will be different from each of the sample depending upon their co-activators or activator synthesizer defects within it. So basically, as I previously told, the dopants and defects, these are the very important constituents of a phosphor material, and basically we can term those as an activators and synthesizers. The activators are nothing but the lumination centers. For suppose if we incorporate some foreign ions into the basic host structure, then it will show the luminations, which is basically the luminations of that foreign particles. Depending upon their energy level and outer shell, they can show different kind of emission and absorb different kind of excitation lights. And synthesizers, sometimes activators may not work in the host. They may not pump effectively from the external light sources. In that case, some synthesizers are needed to sensitize those activators. Basically, sensitizers are transfer the energy, their energy, or become a mediator to transfer the host energy or external energy to the activator, so that activators can pump efficiently and show the emissions. Sensitizer, we can dope from the external, some external also we can dope or incorporate in the host, and also some stoichiometric defects may also generate during the synthesis, which can act as a lumination centers or as a sensitizers. For example, if recent work, I want to give one example. So we incorporate europium 3+ ion and oxyfluoride materials, but europium 3+ ions were not showing efficient emission. Then what we have done, actually, the sample we have heated in the vacuum atmosphere. During heating in the vacuum atmosphere, obviously some oxygen defects has been generated, which acted as a synthesizer for that europium ions, and we have found the luminations after the heating in the vacuum atmosphere was increased by many fold, 10 folds has been increased. So these are some example, and in for international defects which can act as a sensitizer. And another example I would like to give, one work we have doped europium 3+ in zirconia. Then we have found that europium 3+ have a very less emission. Scientific point of view, then we thought what kind of co-activators can be effective to pump that europium emission. So we found that according to the matching energy level diagram, dysprosium was one of the suitable choices for using as a synthesizer. So we co-doped the DY, and we have found that external doped ionic energy transfer also can be used to sensitize the europium this one. And we have optimized the sample, which showed the emission 7 times higher than that of the sample without dysprosium co-doping system. One of the efficient, if you consider the broad emitting system, then one of the efficient examples of the sensitizing effect you can find in Mn2+. Mn2+ have a DD transition which cannot be pumped by external sources effectively. So definitely some EU2+ or cerium 3+ ions are needed, which can effectively transfer their energy to Mn2+. And in that way, we can tune the emission color also. For example, europium is giving green emission, Mn is giving red emission. So if we increase the Mn2+ ionic concentration in a europium optimized dope system, then automatically due to the transfer of energy, europium energy will be reduced and manganese energy will be increased. And you can get a tunable emission color starting from green region to red region. In between, you may find the white region also, which can be effective to produce single white emitting sources. So I just went to for detail, but now again I am returning to the basic. So I will not go much detail because, as you know, that efficient host materials oxides are known, particularly YAG, carnates, Zn oxides, Y2O3, which are suitable more for rare earth ions. Then you also know that U2 plus and cerium 3 plus, which have a band structure, band energetic structure. Though for those ions, most suitable are nitrides, aluminides, these kind of sources. Okay, for the rare earth dopant, you know that europium, cerium, U2 plus, all are well known, and defects are mainly oxygen vacancies, defects, fluorine vacancies. These are the interstitial defects which can work as either as a luminance quencher or may be effective to enhance the luminance efficiency. That depends upon the host structure and their band gap. Now we know that rare earths are effective, very effective as a luminance, which can act as a very good luminance centers, because they are very effective to absorb the from starting from VUV to near UV to blue region emission, excitation, and then they can emit a broad emission ranging from, I think, UV to NIR or far IR, which can have effective applications in lighting, laser, display, sensor therapy, and dynamic imaging, etc. But one of the important thing is that if you produce any optical materials using rare earths, those will not be a cost-effective things, because rare earth itself is a costly, and we need to use very pure, highly pure, that is 99.99% of rare earths as a dopant, percent pure rare earths as a dopant. So automatically its cost will be high if we are using very high pure rare earth ions. So whatever the display materials or lighting materials or laser materials produced by me using on the basis of rare earth ions, those will be a little costly. So these things is the major concern nowadays, research on lighting materials. So it is very necessary to reduce the cost of the materials. Now, why we are focusing on nanophosphor, it is well known that it have a quantum confinement effect, and due to the high surface area, it have a high surface absorption probability. That means low light scattering, because if any materials are confined towards the quantum dot, then obviously it will shaped as a spherical, which have a low optical scattering. Then, as I mentioned, large surface to volume ratio will enhance the interaction of incident photons. That will definitely enhance the brightness of the emission. Then it have a high packing efficiency. Again, it will reduce the scattering, and it is very effective for the display kind of application also, where high color homogeneity is a very important necessity. Now, as you can see that these are the sample example of the nanophosphors property, including morphology, photolumination, as well as illuminations. From the first figure, you can see that these are the very uniform shaped particles, narrow size distributions are there, due to which optical scattering will be lower, and packing density high. So these you can, for the display application, what is the main important thing? You cannot use in the powder form. You have to use either layer form or thin film form or coating form. But that packing density must be very high, due to which we may not find any pores, and the color distribution will be high. So as you can see from this figure, these are the most appropriate morphologies, particularly due to their spherical morphology as well as the nano size distribution, due to which these are effective for the display usage. Now, due to the quantum confinement effect, Okay, you can rise the doping concentration relatively higher than that. You can that optimum concentration usually higher than that of the bulk materials, and this is the reason you will find lumination quantity in the nanomaterials are very high concentration of the doping, due to which you will achieve more intensity than that of the rare earth ion also. Here are the systematic assessing some example of the comparative emission spectra of the some sample produced in the bulk as well as the nano form. And as you can see, the direct luminations image, the color purity, brightness, glowing and color homogeneity in the nano analog is much higher than that of its bulk analog. So we are focusing towards the nanophosphor from this point of view, towards this talk. But one of the important criteria of the nanophosphor is fixing its synthesis. As you know that nanophosphor have a higher surface to volume ratio. So definitely its surface contain much higher surface defects. Now, as I mentioned earlier, defects can be illumination quencher also. So it is very necessary to focus on the synthesis of the nanophosphor to produce its crystalline form. We call it nanocrystalline, which have very less defects, optimized particle size, narrow size distribution, that automatically will give the higher brightness luminations. Therefore, synthesis need to be focused. Then crystal engineering. Of course, crystal engineering is a very important mechanism to increase the luminations, not only increase the luminations efficiency, but also tuning the luminations color, absorption thickness, full width half maxima, which are also very important parameters to reach the desired property of the light. Suppose if you want to use the phosphor materials for the lighting application, obviously you should have the full width half maximum of the emission spectrum must be very high, so that it should cover most of the visible region. Then excitation point of view also, its absorption need to be very high. It should not shifted towards blue region, because towards blue region around 480 nanometer and all, it is not good for human health, particularly human eye, as it produces some irradiation in our cells, human cells, brain cells, eye cells, etc. Then it is mostly should be located in the either UV region where there is no skin harmness will be there. I think it is called UVB or UVC. At present, I am not remembering. Then most of the cases now researchers are focusing on either UV near UV region from 300 to 360 or violet region around 400 nanometer for getting the excitation peak. Simultaneously, the excitation broadness must be must be very high. So there are two kind of systematic approach for synthesizing nanomaterials, top down and bottom up. I think these are all well known to all the listeners, so I am not going into the details. Particularly if you want to synthesize nano powders or powder form of nanoparticles, then the main important synthesis mechanism you might be knowing, those are solid hydrothermal co-precipitation, ball milling, combustion, etc. Now, solid state associated with the ball milling is a industrially acceptable technique for producing nanoparticles, because it can produce mass particles, scalable synthesis within a very short period, or it is very easy also to handle, to understand. So you just mix the precursor, introduce into the ball milling, then use higher energetic planetary or horizontal ball milling these things, then automatically the particle will be crushed and it will reduce the size if you can introduce some surfactant also. But these continuous mixing and this continuous grinding, mixing and substantially heating at higher temperature will introduce so much surface defects or lattice defects, which is not promising for the luminescence application. Those can reduce the luminescence, particularly any other optical properties also very effectively. And therefore this solid state technique is not suitable for producing the nanophosphor which you want to use in the display applications. Therefore, people adopted white chemical reaction like soil gel co-precipitation, hydrothermal compression. But in all these techniques, you produce the solution in the first place, then you are heating the solution by conduction type of heating. That means heating will be more appropriate near to the vessels, but between the vessels and all, the heating will not be appropriate. Therefore, obviously, controlling the particle morphology and particle size is not that much easy and effective through this method. So you may find a range of particle sizes starting from maybe 20 nanometer to some micron also. So their size distribution is not effective, but the size distribution is much more effective in hydrothermal technique because it is a closed vessel type of synthesis. Pressure cooker, as you know, that pressure increase and that the things are boiling very fast. Here also the homogeneity of the reaction will be very fast when that is cooked and the vessels, closed vessels, but it is taking too much time, 20 hours, minimum 10 hours. And the production is also very low. Combustion, another kind of synthesis where synthesis, the internal binding will happen and that binding can effectively increase the reaction homogeneity. But one problem is that whatever the particle you will be getting, those are porous in nature, which may not be effective in so many synthesis kind of things. And this is not that much eco-friendly synthesis because here you are using some urea kind of thing, which will produce some which handling of which is very tricky. So it is not an eco-friendly item as like that. So if we consider this kind of synthesis technique for synthesis in nanopowder, then we need to approach an effective synthesis route which can not only produce the nanoparticles with high crystallinity, but it must produce those nanoparticles with high production rate within a shorter time. So now, why these nanophosphors are basically nano-sized phosphors are basically needed for particularly display application and next generation PC LED, that I am going to elaborate. This is my Indo-French work. Actually, in the France group, what they are doing, they are, as you can see, they are producing nanowire LEDs by their state-of-art molecular beam epitaxial method. Here, these nanowires actually having the dimension of few nanometer, and between two nanowires there are very small size, maximum 100 nanometer space is there. So you need to, these nanowires actually emit either UV light or blue light. Now, if you want to use for the lighting application, blue light you cannot use. So you need to incorporate some yellow phosphor here, which can be effectively excited by the blue light of these nanowires, nitride nanowires, so that blue light can excite those yellow phosphor to emit the yellow light, and combining with the blue and yellow light, you can see the white light. Okay. So what here happening? Our target is to produce the nano-sized particles, which can be confined between the two nanowires. Okay, so that they can effectively excited by the light irradiated by the nanowires and can produce the white light or characteristic light of the combination. So one demonstrated work also has been published recently. As you can see, we produce nano-size particles having the diameter actually below 200 nanometer, then which are confined in some this kind of little bigger nanowires, I think 500 nanometer. Then you can see that is glowing a very efficient light, having the external quantum yield of 40%, which is industrially acceptable for the commercial lighting. Now going to the demonstration presentation. With that, I will conclude later. So here, as I mentioned earlier, that now we have prepared some non-rear arc based deep red emitting system, which are not only effective for lighting application but also effective for various kind of display applications. Mainly, these are not doped by any rear earth, and quantum efficiency also we found very high, and obviously these are cost effective. So here actually not, we adopted initially the sol gel synthesis, but as you know that discrepancy of the sol gel technique, which I informed earlier. So we need to increase the rapidity of the sol gel synthesis and homogeneity of the reactor precursor also. So what we have done, this phosphor LiMg RbGa18, this is a well reported red phosphor doped by Mn4 plus, which is showing deep red energetics, this one characteristic under the both UV as well as blue light. UV means from 300 to 360, 350, and blue light of 410 nanometer as well as 460 nanometer also. So first we synthesize by this by the whatever the reported method is there. That paper has been published in Inorganic Chemistry, which synthesized by the solid state reaction technique. We adopted the same technique first. Okay. Then what we have done here, one more thing is to inform that here this Mg is in the reported paper. Mg is not incorporated. That is only Li3RbGe8O18. So that phosphor only we synthesize by solid state reaction first. Then we introduce a new technique. It is introduced by our research group only exclusively. We have submitted patent on also that one. That is microwave assisted solid state diffusion, where in the solid form we are using solid liquid form of the precursor we are using. Then one microwave synthesizer we introducing the mixer. As you know that the mixing in the solid state is very poor because the reaction, the mobility of the solid particles are the lowest. Then what we have done here, solid liquid precursor mixer we have introduced. Then we just introduce microwave heating. Microwave is a not conduction type of heating. Microwave can enter into the vessels and can react with each individual particles and effectively enhance the nucleation reaction homogeneity, and the reaction also become very rapid. Then what we have done, this precursor after drying, after microwave heating and followed by drying, we introduce into the furnace. These are the second technique. Third technique what we have done, microwave assisted sol gel route, because we need to lower the particle size. That is our main aim. Here what we have done, we with the citric acid and all we introduce, and we actually make a solution, transparent solution. Then we introduce in the same microwave synthesizer, okay, and we collected precipitate in this case, and then drying, and we heated very lower temperature here in the compared to solid state reaction and microwave assisted solid state diffusion technique. This technique requires required a relatively lower temperature annealing, and you can see in the daylight form it is showing white powder, and under UV it is showing bright red emission. This red emission will be further increased by co-doping of magnesium that I am going to discuss now. This is a structural study. Some actually we have found impurity phases also, Lig409 and Li3RbGe8O18, because as I mentioned earlier, this is a relatively lower temperature heating. But one of the interesting thing is that this is showing much higher emission than that of the solid state reaction, which is already reported. Because this impurity, because of two reasons. First reason is its crystallinity, lower defects, and second thing is that whatever you are finding these impurity phases now, these impurity phases actually providing additional sites for Mn4 plus incorporation. Normally Mn4 plus always incorporate into the octahedral sites, as you can see here. Here G is providing that octahedral site, but same Mn4 plus ions, if it is going tetrahedral site, here you can see these are the tetrahedral sites. Green one are the tetrahedral sites surrounded by binding with 4 oxygen atoms. If Mn4 plus going to the tetrahedral site, this is not showing emission, but it is going octahedral sites like this, then it is showing efficient emission, and these impurity phases giving additional octahedral sites which can afford to more and more Mn4 plus ion, and thus illumination has been increased. Regarding the morphology studies, solid state synthesis method, as you can see, it is yielded particles having the micron size, and as I mentioned earlier, particle size ranging from some nanometer, some 1 nanometer, I don't 500, I think 100 nanometer maybe, to some micron bulk particle, 5 micron, 6 micron, 10 micron evenly. Okay, microwave assisted diffusion technique is relatively better because it is showing little growth of the particle and little more homogeneity than the solid state part. As you now need to notice that microwave assisted sol gel synthesis, these are the showing much more homogeneous particle, much more formed particle than that of the solid state and microwave solid state derived particles, and the particle size also around 200 or below 200 nanometer. Particle size distributions are also little more, much more homogeneous than that of the solid state microwave, which can be understood from this as well. Then what we have done, we have optimized the microwave power also, and as you can see, at microwave power of 180 watt, it is showing very homogeneous particle, as you can see in this figure number D. And from the high resolution TEM spectra also, you can see it is the fringes and all are very aligned, showing the crystalline nature of the particles. So we adopted this optimum synthesis condition having the microwave power 180 nanometer and microwave solvent technique, obviously. Okay, these are the photolumination study as I discussed earlier. As you can see, the microwave assisted sol gel technique is showing much more efficient emission than that of, if you see the scale, than that of the microwave assisted diffusion and solid state technique. So I already discussed. Most important thing, these particles, microwave assisted sol gel technique, deeper red region having the 100% red color purity, both under the response of UV LED as well as the blue LED. Now, most important thing is it is excitable at 455 nanometers, so it can be used as a best combination of VIAC to enhance its color rendering index for the resultant white light. These are the low temperature PL synthesis that I am not low temperature PL measurement of the phosphor of the optimized, for that I am not going to the details. What I need to show that one later on, we optimize the microwave power. Okay, and later on from here with the optimized synthesis, what we have done, we have incorporated various kind of mechanism to enhance the luminescence efficiency. Here, what we have done, we introduced Mg doping. Due to the doping of Mg to the lithium side, it is doing two things. One thing is that first thing is that it is actually increasing the luminescence efficiency a lot by providing the more octahedral site. Now question is how it can create more octahedral site, because it is Mg2 plus and lithium is 1 plus. What happening actually, we predicted that Mg2 plus in order to compensate, it is attracting more and more surface oxygen present in the surface, so automatically it is reducing the surface defects, creating more oxygen, lattice oxygen, and those lattice oxygen binding with the magnesium, producing more and more octahedral size MgO6. Okay, which can
Subhrata sir, sorry for interruption. You have only 2 minutes. Sir. Okay.
Yeah, 2 minutes I'll conclude.
Okay. Conclude, sir, please.
Okay. So what happened then? Mg6 it is forming. Now to experimentally verify whether the surface oxygen reducing or not, we actually also have done the XPS analysis, where we have found that the surface oxygen efficiently reduced after the Mg doping. rather than the oxygen in the lattice site. So optimum phosphor actually showing very good illumination, thermal stability also, as it is maintaining around more than 50% luminescence efficiency at the 100 or 125 degrees centigrade, which is very acceptable to be applied for the light emitting application, making the devices. Then now what we have done, we have in order to make it a good counterpart, the optimum red phosphor counterpart of the, we have to know that whether there is a absorption, reabsorption, whether if it is absorbing the emission of the YAG, then it is very difficult to use it in the making the white light, because then the intensity of the resultant white light will be lower. So we have compared the excitation of the this phosphor with the emission of the YAG, and we have found the overlapping region is very lower. As you can see in this spectra, it's very lower. So that can be used to mix with the YAG for making the white light, and simultaneously you can see the intensity is much more higher than that of the commercial YAG. This is yellow's emission is the broad emitting yellow is the commercial YAG we have compared with our optimum red phosphor. Simultaneously, what we have done, we have coated our optimum red phosphor on commercial UV LED of 280 nanometer, 365 nanometer, and commercial blue LED of 460 nanometer. Then we have found that these are effectively converting the excitation photons to the visible red light. Finally, this is the final slide. Finally, we have mixed our optimized red phosphor with the YAG at a various ratio. As you can see, this is without red emitting, without red phosphor. Then we systematically increase the red phosphor content. That means YAG to red. We systematically increase red to YAG phosphor ratio, red content particularly, and that due to which the resultant color of the resultant white LED also, you can see it is changing. This is showing without red phosphor, which is showing bluish white light, that is cool white light of CCT of 6952, which is not acceptable for in commercial indoor lighting. Then finally, with the increase of red phosphor content, we have found a combination of white light which is showing CCT of 5025 Kelvin. That means it is pure or ideal white light emission, much more suitable for not only indoor lighting but also outdoor lighting also. Meanwhile, the color rendering index also increased from 71 to 92. 71 is the YAG system with the LED, and 92 is the combined system of YAG, our red phosphor, and the blue LED. So moreover, we have also coated our red phosphor on a blue LED of 410 nanometer. As you know that the blue LED peak at 410 nanometer and deep red light at 659 nanometer, those are well matching with the absorptions of chlorophylls. That means what? That means you can see this green line is the absorption of chlorophylls. This is the blue region. This is the red region of 659, and our emission also is coming 659 nanometer and with 100% net color purity. So directly it is indicating that this this combination of lighting LED, that means our phosphor combining with the 410 nanometer blue LED, is a perfect suit for its application in the plant growth area, plant growth sector, indoor plant growth sector particularly. So these are the basic results. Thorough research are also going on to reduce its particle size more. So with this, I want to conclude my talk. I would like to acknowledge my research team here at CSI NIST, and the team is known as Optical Materials Group. Financial support from CSIR, CEPIFRA, and SCRB. And I would like to thank you very much, the ICRTR, ESD, BIT Raipur team for inviting me for this talk. Thank you. Thanks a lot.
Thank you very much, sir.
Thank Thank you very much, sir, for your deep insight on the topic nanophosphorus for solid state lighting and display application. Our next speaker is Dr. Balkrishna Mehta. Sir, I hope you have joined. First, apologies are due to you for keeping you wait so long. So without wasting a second, I will briefly introduce the profile of Dr. Balkrishna Mehta. Sir is working as assistant professor in Department of Mechanical Engineering, IIT Bhilai. And sir, Dr. Mehta he is BE in Mechanical Engineering from BIT Durg and received PhD and MTech from IIT Kanpur. Sorry. Now, apart from his PhD, sir has a doctoral fellow ISAE ENSMA, Poitiers, France, after his PhD. Prior to joining IIT Bhilai, sir was an assistant professor in Department of Mechanical Engineering at IIT Guwahati. Sir has many more achievements to his credit, but we will like to hear more the person himself. So the session is all yours, sirs. Please introduce us and share your research. Thank you so much.
Thank you for the introduction. I'll just share my slides.
Sir, you are not audible.
Yeah, just hold on. I'm sharing my slides.
Okay, fine. Thank you.
Yeah, I think it is visible now. Hello?
Yes, sir.
Yeah.
You are audible and slides are visible as well.
Thank you. So good morning to all of you. So I'm going to talk about this thermohydrodynamics. So heat transfer and hydrodynamic behavior of a flow in a porous media, right? So we are mostly, we are aware what is the porous media. For example, just to introduce, the porous media is something like this structure which you are seeing here, right? Okay. Porous media, the earth surface is a porous media, right? Our earthen pot where we used to cool the water for drinking, that is also having the pores, right? And why it is important? So there are many natural flows taking place through the porous media. Our RO waters or water purifiers, all of them have the porous media. There is always a membrane through which the flow takes place, right? And sometimes it is used to filter out the impurities. Sometimes it is used to flush out something, or for example, in the trees, there are porous media which are responsible to transport the water from the roots to the leaves, right? In our body, there are porous media which transfers or which is used to transport different bodily fluid, for example, blood, plasma, or many others, right? So there are many activities takes place where the flow through the porous media is important, right? And why it is important in terms of heat transfer, if we see here, this figure is showing you about a kind of heat pipe, a loop heat pipe, right? Heat pipe, if you are not aware, heat pipe is used in our laptops and in a different form in our smartphones also nowadays, right? So in heat pipe, there is a section called the evaporator section, right? This section. Here we have the porous media. And why do we have the porous media? The application of the porous media here is, if you see the whole construction of this heat pipe, here you will see that liquid line, right? So liquid is being transported to this location, and here the liquid will try to take heat from the surrounding and or the area which we want to cool. So for example, if we talk about the mobile phone or laptop, this will be the area where the processor is located, right? Processor is the area where the heat generation in the laptops takes place, and we need to keep the temperature of the processor at a given within a given limit. For example, we don't want to heat it up more than 60 or 55 degrees centigrade, right? So that would be the area. So this is our evaporator section. Now what it does, so here in the evaporator section, as it's a porous medium, then we know that from the concept of our earthen pot, that in the porous medium, this liquid will diffuse in the droplet and it will be spread all over the surfaces. Here, all over the surfaces, the liquid will spread. And as it gets the heat, it evaporates from this surface. So when it evaporates, it takes large amount of heat. And when the evaporation from this porous media external surface is taking place, parallelly, the liquid which is here is also being transported to the surface, right? So this phenomena always takes place, and there is a vapor. This the generated evaporated vapor will transfer through this line. It will come to the condenser where we cool it and again convert it into the liquid. So this way, this phenomena takes place. So in general, heat pipe is the device. It's a very simple device where the condensation and boiling, so evaporation and condensation is continuously taking place in terms of taking the heat away from the desired location, right? Porous media helps in a way that this does the two tasks. One task is transporting the inner liquid to the surfaces so that the necessary evaporation can take place and the required amount of heat can be taken away. One. Second thing, to make this flow in whole loop, right? The necessary pressure drop, the required pressure drop, is also generated by the porous structure, right? So there will be pressure drop required to overcome the frictional factor here, the pressure drop required to overcome the frictional factor in the vapor line. Then there, as we will have the liquid vapor interface, then there will be a pressure drop of interface, right? And there are many viscous pressure drop and bends and this, there are many pressure drops. So this porous media should be strengthened enough to generate the sufficient pressure drops so that, so for example, the pressure drop generated by the porous media should be greater than or equal to all the available resistive pressure drop in the system, right? So that the flow will take place. So in a way, you can see that this heat pipe is not involving any kind of external pump to make a flow, right? This device is a self-sufficient, and just because of the temperature difference is responsible to create the pressure difference, and this pressure difference is actually governing the flow. So no external pump is required. Whenever there is a hot zone, you put this device, it will start functioning, and you should make a cold zone from where you take out the heat, right? So that is why this is very important to understand, right? Secondly, if you see why it is important to study the fluid flow, if you see, we have said that the liquid which is available at the inner surface, right, that has to be transported to the outer surface of the porous medium. So there is always a flow taking place through the pores, right? And that flow is mainly due to the capillary action of the pores, right? If the pressure drop is not sufficient to take the inside liquid to the surface, so that is from this location to this location, then what may happen, there is no fluid going there, but heat is continuously coming. So it may become a dry wall and temperature can suddenly shoot up and the device can be, I mean, laptop or mobile or any device can abruptly stop working, right? So that is why the fluid flow as well as the heat transfer mechanism, both are important to study in this type of structures, right? Typically for groundwater recharging, I mean, there is a porous media, we need to know how we can efficiently do the groundwater recharging. In RO, our household RO, there is a lots of water is as a waste, right? So we can do some study in the candle, I mean, where the flow is taking place through the porous media, so that we can actually reduce the wastage of water from it, right? So if you see that this is the porous media, in reality, if you see that this is the porous media which is used, right? So during that, I mean, in this, when we study the fluid flow and the heat transfer, we see that there are few equations which are required, right? So you see here, this equation is the Darcy equation. Darcy was the one who studied this fluid flow through the porous media, and this was mainly this study was mainly resembling to the flow through the earth surface, right, or the water recharging surface. So you can see here the pressure drop is actually a linear function of the velocity, and here mu is the viscosity and k is the permeability of what, of the ground surface, right? So this equation is valid, but it has its limitation when the flow velocity is very small. So Reynolds number is significantly low, right? Then only we can, I mean, this is order of 1, not 1. So then only these Darcy equations are valid, right? Where the pressure drop is directly linearly proportional to the velocity, right? But when the flow are higher, for example, in our RO systems where we want high discharge, so as we want high discharge, the flow through the porous media should also be very high, right? So in that scenario, there are two other parameters which comes in the pressure drop, right? So here is this, the second term is coming because of the inertial effect, right? So you can consider it as a kind of drag, the form drag, right? And the third term is coming because at the pore level, there is a boundary layer generation takes place and the diffusion of the flow takes place. So for example, if we have, let's say, if there is a pore of this size, right, there are multiple pores even like this, and if there is a flow taking place, right, and it's a large Reynolds number flow, relatively speeded flow, then what will happen, as it is flowing over this pore wire, so there will be a boundary layer generation taking place, right? So this boundary layer generation will actually give rise to this diffusion term, right? At the same time, as the flow is taking place, so this pore area, the pore area is actually resisting the flow. So this inertial drag is coming because of the blockage of area, right? So apart from the Darcy term, we have the two other terms. So one is due to the inertia, another is due to the viscous diffusion, right? So this actually completes the flow equation, the Navier-Stokes equation, right? Similarly, if we see the heat transfer equation, the energy equation here in this case, so we see that there are two different techniques. In one techniques, we can consider that whatever is the fluid available here, so if this is a pore, right, whatever is the fluid flow taking place over this, we consider that solid surface is having the temperature same as the fluid which is in the contact, right? So this condition is called the local thermal equilibrium condition, right? So if local thermal equilibrium condition and this condition is satisfied, so the energy equation becomes a simplified and we have this energy equation. But typically this is not the case, right? In general, there is no local thermal equilibrium. So we have to go to the non-equilibrium case. And in non-equilibrium case, we actually have the solid surfaces having a different temperature than the fluid in contact, right? So there is parallelly flow is taking place at the same time the convective heat transfer from or to the pore to or from to the fluid is taking place. And that heat transfer is taken from this surface, right? If you see that if the heat transfer coefficient is very sufficiently high, so this temperature actually comes close to each other, right? So in that scenario, we can say that this this whole term becomes insignificant and they can merge to the LTE condition. But for the general scenario, we cannot say that. There is a finite amount of heat transfer coefficient and there is a finite difference between the pore scale, pore temperature and the fluid temperature which is in contact. So if we are not considering the local thermal equilibrium, then we have to solve two energy equation, one for the fluid domain, another for the solid domain, right? So you can see that the fluid domain equation is given like this, the Navier-Stokes equation just modified for the porosity condition, and the solid equation. In the solid energy equation, there will not be any advection term, while in the fluid domain, we will have the advection term. So with this equation and the flow and energy equation, we do some modeling, right? And we found out some interesting results, which I will discuss. So these are just pros and cons. So yeah. So you can see in nature, we do not have a control over the porous surfaces, right? I mean, the porous surfaces can be randomly oriented. The size of the pores can be randomly distributed, right? But as the engineering is growing, right? So nowadays, with the advent of the 3D printers, and 3D printers has come up to the level where they can fabricate anything. So we can actually fabricate the structured porous media. So the benefit of a structured porous media is the many geometrical parameters are in our control. For example, whatever you are seeing in the figure, I mean, this is a bigger figure. This is not the size of that. You can see that the pore diameters are almost same. We can fabricate it, right? And we can evenly manage their distribution. So for example, if I have to do the analysis of it, I need not to do the analysis over the whole pore, because I can just take a unit structure of it, a unit cell by which this pore is being made, and I can do the study, right? And I can multiply it for the given dimension, right? So that is the usefulness. So from this objective, I mean, from this point of view, we actually try to compute, to fabricate, not fabricate, but computationally we made the domain in the of the structured porous media, and we made 4 different types of porous structure, as you can see here, right? These 4 different porous structures are made, and here you can see that how one cell is looking like, right? So there are the flow domain kind of thing you can see, there are the flow passages, right? Similarly in all the structures, right? So we made these 4 types of structured porous matrix, right? And we studied the fluid flow and heat transfer. So this you can see the mesh. One show, so the top row shows you the void region, while the bottom one is showing you the solid region, right? Yeah. So here, as we are having the solid and void region, just to vary the porosity, right, and not making the different structures at different time, what we did, we took help of a strategy where in solid, we took the 3 different types of solid region. In one, we just kept the solid region as a solid, right, and void as a void. So in void there is a fluid, in solid there is no fluid, it's completely rigid solid, so nothing can pass. So whatever needs to flow, it will flow through the given opening, right? So it may flow through like this, okay? So these are the flow region. While in the other case, in type 2, we consider this solid domain, which was here in type 1 was completely solid. We consider that this is also a fluid domain. This is also fluid, this is also fluid, and they are just separated by a 0 thickness interfaces. While in type 3, we consider this solid domain also containing the small pores, right? So this way we can actually vary the porosity of the different structure by considering 3 types. So if we see the effective porosity in type 1 is 0.32, effective porosity in type 2 is close to 1, it's very high, not 1 but close to 1. Why close to 1? Because we are considering these interfaces which are not taking part in the area, flow area, right? And in type 3, as the solid is also containing some smaller pores, the porosity value is 0.54. So porosity, we define porosity as like this: the area available for the fluid to flow divided by the total area, total volume, right? If it is the surface, then we have to take the area. So that is the porosity. If the porosity is high, or if we say the porosity is 1, it means there is nothing which is obstructing the flow of the fluid, right? But if the porosity is, let's say, less than 1, we say that some amount of volume is being obstructed and there is no flow taking place in those areas, right? That is the meaning of porosity. So one, we can clearly see that if the porosity is low, it means the flow area is very less, and the flow area is very less, then there would be many pressure drops. At the same time, you are seeing here the path of the fluid, path of the flow which fluid will follow is not the straight, right? So for example, if I want to make a flow from this point to this point in the porous media, the fluid should follow this path, right? Why? If it would have been a normal flow, there would be a straight line through which the fluid could have gone from point 1 to point 2, right? So there is another quantity called the tortuosity, and this is defined as the actual path length of the flow divided by the minimum path length of the flow. So actual path length is this one. Minimum path length is the shortest distance between the 2 points, right? So from here we can say that tau, the tortuosity, is always greater than or equal to 1, right? How this tortuosity is important? Because this tortuosity is actually responsible for the pressure drop required to make the flow, right? So this is one of the parameters. Yeah. So the governing equations for the Navier-Stokes equation, the flow equation is this, right? And the energy equation is this. If we see for the microporous region, then porosity will come into the picture, and these equations will be little bit modified like this, right? So from here, these are the boundary conditions. So inlet and outlet are called symmetric boundary conditions, right? Because symmetric because this is the unit cell. The computation is being in the unit cell, and this unit cell is multiplied in some whole numbers that will make your 4 porous structure. So apart from making, in spite of making whole porous structure as our computational domain, we can just study in one unit cell and we can reproduce the result for whole porous domain, right? So these are the boundary conditions which we have used. And now I come to the results, right? So first to see the model, is it okay or not? We did some grid independence test. So we made 4 different types of grids, right? And what we see here is that when we go to the value of grids very finer, from let's say nodes are 47,540 to 63,200, what we can see is the difference in the pressures, right, in the 2 values are very less, right? So it's 0.19% from finer to the finest, right? So that is why we did our simulation at this grid. We did not choose this because it is unnecessary increasing the computational cost without any sufficient increase in the accuracy, right? So that was the grid independent test. And then the validation of the model was used by doing the simulation of the pressure drops. So there are some pressure drops given in the literature. So we tested our model against the literature, and we are seeing that it's a very good match with the given pressure drop value or the pressure gradient value with the literature. So once confirming that models are accurate, boundary conditions are correct, equations are okay, and all our different settings are fine, we did the simulation, right? So yeah, so we used this equation to calculate our parameters. So our main aim, whenever we make the porous structure, our main aim is to calculate the permeability and the inertial drag factor, right? This permeability, you can consider it as the same as the thermal conductivity, right? So here the permeability, if the permeability is large, it will allow more fluid to flow, right? Similar as if the thermal conductivity is large, it will allow more heat to flow. So, so permeability is analogous to the thermal conductivity or the concentration or the diffusion coefficient of the mass flow. These are the same. So main aim, whatever the porous structure we have made with the known porosity, what would be the permeability? So porosity alone is not the parameter, but porosity should be some way related to the thermal conductivity, not thermal conductivity, the permeability, and this permeability will be responsible for the pressure gradient, right? So that's what we wanted to calculate. And as I told you, the flow will be at higher Reynolds number, so the inertial drag factors is also important. So K and CF are our main parameter, which we wanted to calculate for the given Reynolds number in terms of the mass flow, right? Yeah. So as we see the results in the 4 different types of porous structure domain, right? We are having a different fluid flow path, right? So while you can see in diamond, it's a quite longer path to take to cross the same length, right? While in case of IWP and the primitive, it's relatively straighter, right? So all the fluid is flowing through almost a straighter path, while for diamond and gyrode, it's not, right? So as I defined the tortuosity, you can see that these two are relatively straighter in the flow, so the tortuosity is actually close to 1, while in case 1, type 1 and type 4, so diamond and gyrode, we can see that the fluid has to move through a longer path, right? So that is why the tortuosity, the effective length through which the fluid is flowing, is high, right? So that is why the tortuosity is high. So if we, from the basic knowledge of fluid mechanics, we know that if we have to take a longer path then the pressure drop should be higher, right? Because you have to overcome the larger frictional pressure drop of the path, right? So that way, from this simulation, we actually calculated the permeability and the inertial factor. How, I'll tell you. So we got the data for different mass flow rate, right? We got the delta P by L for different as a function of mass flow rate, and we plotted it, and we did the curve fitting in the all different cases. When we did the curve fitting, we got a second order curve, right? I mean, we fit the second order curve. So when we fit the second order curve, you can see here that this equation, which is given in terms of mass, is a kind of quadratic equation for the mass flow, right? So that is why we fit the second order curve. And after fitting the second order curve, whatever is the coefficient we got, so from the coefficient of the first order.
Sorry to interrupt you in between, sir.
Yeah.
But if you can please conclude in
Okay.
2 minutes.
So from here, this we will get the permeability, and from the second order coefficient, we will get the inertial friction drag, right? So this was the case, and we can see that, I mean, for different types, there are different curves, right? See, for type 2 porosity, where everything is fluid, we have the fluid domain. I mean, the flow path is not so straighter in case of IWP and primitive, right? Similarly, you can see flow domain in the third case, where the solid is having the micropores, right? So tortuosity can be seen, and based on this tortuosity, this permeability and the inertial friction drag is calculated. The same, right? Yeah, so that's it. I think I should conclude now. If you have some questions, you can let me know. Hello?
Thank you so much, sir,
Yes, sir. So I concluded. So if you have
for
any questions,
wonderful talk and sharing your
Okay, thank you very much, sir,
yeah,
for your nice presentation. Thank you, sir. Thank you. Ma'am, please move forward.
Now, our next session chair for our technical session 4 is Dr. Durga Sharma. So we have here Goddess Durga in the attire of Goddess Saraswati, because ma'am is related in intellectual field and she has given her contribution in the field of education. To start with her bio, madam as lecturer in Government Polytechnic College, Raigad, and madam has been an assistant professor in electrical engineering at Dr. C.V. Raman University, and she has also worked at different other educational institutes. Coming to academics, she had her PhD in electrical engineering from Dr. C.V. Raman University, Bilaspur, and had her MTech from VIT Durg. She has published 54 papers in national and international journals, and she has attended different workshop, conference, seminars, which amount to 21 in number. She also has professional affiliation of a number of institutes like the International Association of Engineering, IAENG, and the Society of Digital Information and Wireless Communication. So we are privileged to have you with us, ma'am. Welcome to the session, and thanks for doing the honors. Now, in this session, we have invited talk by Dr. Pradeep Kumar Sonwane. Let me quickly introduce Sir also. Dr. Pradeep is assistant professor at NIT Sikkim, and Sir has 6 years of experience to his credit. Sir has done his PhD from NIT Jamshedpur and mechanical engineering from GEC Pune. His area of interest include power quality, control system, power electronic, renewable energy system. He has published more than 18 papers in national and international journals, and he has 3 book chapters to his credit. Now, sir, the platform is all yours. Please introduce the scholars. Thank you so much, sir.
Hello. Very good morning to all. Am I audible?
Yes, sir.
Okay. So let me share my slides. So I have to give presentation up to 30 minutes, na? Half an hour?
Yes, yes, sir. Yeah.
Okay. So this is my topic about the today's presentation. D-STATCOM performance in terms of power quality and its integration with distributed generations. So here we will see the performance of D-STATCOM in terms of power quality, and another factor we will see how we connect the renewable energy sources on the DC side of the D-STATCOM, and we will see how we are getting the power quality performance. Okay. So these are the presentation outlines. So we'll discuss about some research work about the D-STATCOM, what are the various classifications, what are the principles behind that operation of D-STATCOM, how we can design the D-STATCOM parameters, and what are the control techniques are there, and we will take one case study. With the help of case study, we'll see how we are improving the power quality. And another phase is that we will do some integration with the renewable energy source. We will take one PV based renewable energy source, and we will do integration, and we will see how we are getting the power quality performance. So these are some outline. So modern power system, we are very much concerned about power quality. So today customer want good amount of power. Okay, so they don't want any disturbance in the power supply. They want uninterrupted power supply. So today, as a customer, everyone wants that the power should be in proper way. There should be good quality of power. So today, what we are doing, we are using modernization of industry. We are using too much computers in our industries. So due to these devices, we are getting power quality problems. Another way is that also we are getting power quality problem if you are getting integration with the renewable energy source. Then also we are getting power quality problems. So these problems we are facing today. So we have to improve these problems. So there are various devices are there. So first I want to discuss what are the power quality problems are there in power system. Harmonics, reactive power, burden, voltage sag, voltage swell, transient, over voltage, voltage unbalance, frequency variation, voltage fluctuation, flicker. These all are the power quality problems which are based on the voltage based, and some are based on the current based. So to improve this power quality problem, so research have been started in time to time. Initially we are using passive filter, then active filter, then hybrid filter, then custom power devices. As well as technology improving, so we are going in the better way to improve the power quality problems. So here in this talk I will discuss about the one of the device to improve the power quality problems, and that device is the D-STATCOM. And D-STATCOM is basically one of the custom power devices. Custom power devices, there are three devices are there in custom power devices: D-STATCOM, DVR, and the UPQC. So based on the connection in the power system, these are categorized. So D-STATCOM is connected in parallel with the power system, DVR is connected in series with the power system, and UPQC is connected in series and parallel both with the power systems. So today I will discuss about one of the custom power devices. I am taking one device, that is the D-STATCOM. So what is the objective as there to this? We will do the MATLAB based model of the STATCOM. MATLAB Simulink is easily available. Today we are doing research, 80% research work are related with the MATLAB Simulink. Okay, so I am focusing about the MATLAB Simulink. So we will do the modeling of the STATCOM with the help of MATLAB Simulink. And another phase we will do the that model, and we will connect the DC bus with the solar plant, solar power systems. And we'll observe the how we are getting the power quality performances, how we are improving the power quality. So this is the one basic structure of the STATCOM. As I told that it is connected in parallel with the power system. So various classifications are there, and the classification is based on the converter based, topology based, and the phase based. If you are going converter based, then there will be current source converter or voltage source converter based. If you are going topology based, then there will be various without transformer, with transformer configuration, various inverter topology configurations are there. And if you go about the phase based, then single phase, three phase. In three phase there are two categories: three phase 3 wire, three phase 4 wire. So in this way we can categorize the STATCOM, and we can do the some topology, and we can compare the performance. So this is the basic structure of a converter based classification of the STATCOM, and CSC based and the VSC based D STATCOM. Topology based D STATCOM is also there. And this is the another configuration of supply based D STATCOM. This is a single phase D STATCOM. And this one is the three phase D STATCOM, that is in three phase 3 wire arrangement. And this is the another topology of three phase 3 wire D STATCOM, that is we are using H bridge based converter. This one is another topology. We are using 4 wire based D STATCOM, that is we are using three phase 4 wire system in power system, and we are providing 4 leg voltage source converter. So principle and the control of D STATCOM. What is the principle behind D STATCOM? The basic function of D STATCOM is to mitigate current related power quality problem, current based power quality problem. So current based means if you are getting some unbalance in our power system, if you are getting high neutral current, if you are getting excess harmonics in the source current, so that all are the current based power quality problems. So with the help of D STATCOM, we can reduce that power quality problems. So control algorithms are various control algorithms are there, because control algorithms is very much necessary for any custom power devices. So control algorithm is the objective is that we have to estimate the reference current, and that reference current will feed to the PWM generator, and that PWM generator will generate the pulses, and that pulses will provide to our converter, whatever converter we are using, either voltage source converter or current source converter. So control algorithms are classified also in two ways, and time domain and frequency domain. So in literatures there are various time domain based and frequency domain techniques are available, and these are some time domain based techniques: power balance theory, I cos phi, CSD method, IRPT method, DQ theory, also known as synchronous reference frame theory, ISCT, instantaneous symmetrical component theory, PQ theory. So these all are the time domain based techniques. And some of the frequency domain based technique are there, and that is the Fourier series, discrete Fourier transform, fast Fourier transform, Kalman filter, wavelet transform, Hilbert-Hung transformation. So these are some of the frequency domain method of control techniques. So we have to design how we are getting the DC voltage, how we are getting the DC capacitor voltage, DC capacitor rating, how we are getting the interfacing inductor. So here is some design. So this is the just formula based. So just to put, we have to value, and we will get some parameters. So here I have choose in this work, there are two control techniques, indirect PI techniques and SRF technique, that is synchronous transfer technique. And what we will do here, we will compare the performance in between the indirect PI technique and the synchronous transfer technique, and which one getting better performance in terms of power quality. So indirect PI controllers block diagram is there. So how we are getting set voltage, we are getting terminal voltage from the power system, and we will set one set voltage, that is the reference voltage, and then we'll feed to the PI controller. We will get delta. This delta will give V control, and these two blocks, figure 11 and figure 12, will combine with together in Simulink model, that is figure 13. So same thing here. This is the another technique, control technique, that is a SRF control technique. This is the block diagram, how we are sensing the three-phase load current and DC voltage, terminal voltage, and how we are getting the three-phase compensating current. So this is just mathematical things. So how we are getting three-phase compensating current, we will get from this expression are there. So with the help of this expression, we are getting the three-phase compensating current, and this compensating current will ultimately feed to the PWM generator, and that PWM generator will generate pulses for the our switches, whatever switches we are using in our DC STATCOM. So I have taken one case study. So this is the one power system, three-phase power system is there, and we are taking the load, unbalanced load and a nonlinear load, and we are using here one voltage source converter. And this is the control unit. So we have to discuss about the control. I already discussed about the control unit, that is indirect PI control unit and SRF control unit. So from that control unit, we are getting some current, and that current will feed to the PWM generator, and this PWM generator will provide pulses for the converter switches. So this is the one setup, one case study I am taking. So converter, if you talk about the converter, there we can use various arrangement. This is the upper one is 3-leg arrangement, and a lower one is 6-leg arrangement, topology of the converter. So what are the parameters we have chosen for this case study? I have written there. So every parameters are there: source voltage side and load voltage side, and whatever load we are taking, nonlinear load, and what are the capacitor, what are the parameters we are taking, filter parameter, controller parameter, power converter. Here IGBT/diode we are using. So this is the IGBT plus diode. This is the one model we have developed in MATLAB Simulink, and with the help of indirect PI control technique, because I have already told that we have to compare indirect PI control technique and SRF control technique, and we'll see the performance analysis. So this is the one setup for indirect PI control techniques, and this one is the another setup that is for SRF control technique. Okay, that is developed in MATLAB Simulink. So we'll see the performance analysis in between these two control technique, indirect PI control technique and synchronous transfer control techniques. So after educating these models, we are getting some results. Okay, in case of indirect PI control techniques, we are getting various waveform. Load current waveform is non-sinusoidal because of nonlinear load, and here you can see that source current and terminal voltage both are in same phase. Okay, source current, terminal voltage waveform are in same phase, means we are getting power factor improvement, but DC voltage regulation we are not getting in exact way. Okay, so this is the one drawback of PI controller. And harmonics is also there, and before compensation, if you are connecting DC STATCOM with the power system, if you are disconnecting that system, DC STATCOM system with the power system, in that case we are getting the THD, means total harmonic distortion of source current, that is 8.11. when after connecting the DC STATCOM with the power system, suddenly THD will be reduced, that is 1.69%. Okay, so this is all the case for the case of PI control technique. Now the case of SRF control technique, that is synchronous transfer control technique, here also we are getting load current, non-sinusoidal, and a source current and a terminal voltage also same phase. We are getting power factor improvement, but here we are getting DC voltage regulation around 400 volt, that is in proper way. That is we are getting in proper way, because we are giving the DC link voltage 400 volt in Simulink setup, and here also we are getting 400 volt around. So we are getting good DC voltage regulation here. And also if we compare with the previous case and here SRF technique, the TSD is also very less. That is in before, if you are disconnecting the D STATCOM with the power system, the TSD is 8.11%. After connecting, we are getting less TSD, that is 0.05%. So we can compare these two technique, indirect PI and SI technique, in the tabular form. Without D STATCOM, what you are getting TSD 8.11%, and after D STATCOM means when connecting the D STATCOM, we are getting the TSD in case of indirect PI 1.69 and in case of SRF 0.05. So we are getting less harmonics in case of SRF techniques, means we are getting better power quality improvement with the help of SRF control techniques. So the same thing we are represented in the chartable form. Okay, so this blue one represent the indirect PI technique, green one, and this yellow represent synchronous transform technique. So this is for the 1.69 and another one is for 0.05. So this we have developed in the electrical machine lab also in NIT Sikkim. One setup we have developed, and we have just taking that different load, and that induction machine load we are using, one dynamic load we are using. So this setup we have developed in the machine lab. So I am not going in detail. So now if you go for the distributed generation, how we can integrate the D STATCOM with the renewable energy source, that is PV system. So that in that sense also we can improve the power quality also. Okay, so same setup we use, that is D STATCOM, and what you know about the distribution generation means small power plant is there, means we are producing very small power, and that is the meaning of distributed generation, small power plant we can say. So solar cell we are taking here, small we can, solar cell is easily available, we can use in the floor. Okay, so this is the basic theory behind the solar modeling of PV cell. So PV module is a current source type of devices. So this is a electrical structure, how we are getting PV cell. And here, because we are using in the distributed generation based D STATCOM, we are using two stage converter. One is the DC to DC converter, and another one is the voltage source converter. So for the DC to DC converter, to provide the duty cycle or to provide the pulses to that DC to DC converter, we are using various MPPT, and various MPPT is available. So MPPT means we have to obtain the maximum power from the system. So various MPPTs are there, that is the perturbed observed, incremental conductance, fractional open circuit, fractional short circuit, current, fuzzy logic control. So there are various MPPTs are there. So here I have taken one MPPT, that is incremental conductance algorithms. So this is the flow chart, how we are getting the duty cycle, and that duty cycle will feed to the DC to DC converter. So in second stage converter is there, that there also we have to use one controller, that is voltage source converter controller. Hello, am I audible?
Yes, sir.
Okay.
Yes, sir.
So this is the block diagram, MATLAB based block diagram for the incremental conductance method in MATLAB Simulink, and then the complete setup is there, that figure 30. And there here we are using two stage converter, one is the DC to DC converter, that is boost converter, and another converter is a voltage source converter, and these both converter require the pulse. Okay, so for the boost converter we are giving the pulses with the help of MPPT techniques, that is the incremental conductance method, and for the voltage source converter also we are using one control techniques, and that will provide the pulses to the second converter. So this is the one setup, and we'll see how we are getting the power quality improvement, and these are the parameters. Okay, for this setup, how the parameters are selected: solar panel, boost converter, DC capacitor, DC AC converter, grid. So everything we can take here. Now that we will see the result, how we are getting the performance in terms of power quality. So In case of compensated mode, when our setup, this setup is connected with the grid, okay, this utility grid, then we are getting the TSD that is 3.79%. Okay. When we are disconnecting this setup with the grid, then the TSD, the source current TSD is 31.65%. Okay, so we are getting too much TSD when the disconnecting. After the connecting, we are getting less TSD, that is 3.79%. So there are some waveforms are there, curve of voltage and the current waveforms are there, and this the DC voltage regulation is also we are getting here. Okay, reference value is our 500 volt, and we are starting times we are getting some transient, some fluctuation will be there, and after some times, means after 0.5 second, we are getting some stabilization. Little bit ripple are there, but we are getting stabilization of the DC voltage. So these are the some performance in terms of irradiance, temperature, and the duty cycles. And here also we are getting the performance grid voltage and the grid current and the DC voltage. This is the power waveform, how we are getting the power. And this is the another setup we can use. Okay, we are using combined renewable energy sources. First in first diagram, we are using a wind-based energy system and a PV-based system and a fuel-based system. We are combining all, and this is a mixed renewable energy system integrated with grid. And we are making one DC bus, and that DC bus will provide to the our DC side of the converters. So this is the one setup and the conclusion. So what we have done here, we have done case study, and we have seen the performance in terms of power quality, and we have demonstrated the two power quality terms. One is the power factor, and another one is the harmonics. And we can say that we have compared the two techniques, SRF and the indirect PI techniques, and we have found that SRF technique giving better performance. And also we have done distributed generation based D STATCOM, that can also we have tested for power quality improvement. So in both cases, with the help of DG and without DG, in both cases, what we are getting, that TSD is come below the 5%. If their TSD is below 5%, means that is fulfill the criteria of IEEE 5.9 standard for harmonic limitations. So these are the conclusions. Also, we are regulating the DC bus voltage exact way, and we have done the performance, comparative performance in between the indirect PI technique and SRF techniques. And if you do the future work from here, so we can develop different topology of the STATCOM, because I have used current voltage source inverter based topology. So we can develop for current source inverter based topology, and we'll see the performance. Okay. So power qualities are various terms are there, various power quality study we can do. I have only concentrated on the power factor, harmonics. We can concentrate on voltage sag, voltage swell, transient, so reactive power. So other power quality issue also we can test. And I have used a 3-phase system, so we can use multi-phase system, multi-phase pattern also we can use for the research work. And the function of custom power devices we expand from power factor correction, harmonic mitigation into the improvement of stability in power system. So here we have used a time domain technique. So already I have discussed various frequency domain technique. So we can choose 2-3 frequency domain technique, and we can do the comparative analysis, which one giving the better power quality improvement. Okay. Inverter topology also we can use various inverter topology, multi-level, multi-step, cascade, edge bridge, chain converters. We can change the inverter topology, and we'll see the performance. Hybrid renewable energy system also we can use. Already we have discussed that diagram. There in one DC source we can use the renewable energy PV cell, wind energy we can use, fuel cell we can use. So hybrid based renewable energy system can be used, and we can make one common DC bus, and that from that DC bus we can give supply to the converter. So these are the conclusion, and some references I have taken. Thank you. Any questions?
Excuse me, sir.
Yes, yes.
Sir, I am Kritika. Good morning, sir.
Morning.
I am Kritika Panikrai, student of 8th SEM, Triple E department.
Yes.
Sir, I have a query
Yes.
that we normally use MATLAB for the simulating,
Hmm.
but what are the other tools which can be used, which are user-friendly tools, sir?
Pardon? You repeat your question.
Sir, we use MATLAB in nowadays.
Okay.
Basically, it is user-friendly, but what is the other tool that can be used for simulation and it is a user-friendly too?
Other tools, we can use PaceCAD, ETAP software also we can use. Okay, for simulation work. But that
Okay,
is
thank you, sir.
really not available, I think. Okay, you have to purchase. MATLAB is freely available. You can download in website also, and you can use your work.
Okay, thank you, sir.
Sorry, I am not getting your voice. Hello.
Yeah.
Hello, am I audible?
Hello. Thank
Yes,
you
yes.
so much, sir.
Okay.
Good afternoon to one and all. I am Rashmi Mishra, Assistant Professor of Electrical and Electronics Engineering Department. It gives me immense pleasure to extend to you a very warm welcome on the behalf of BIT Raipur, who has clubbed all of us for this International Conference 2022. The aim of this conference to bring together leading academic, scientists, professionals from industries, research scholars to exchange and share their experience and research result about all aspects of electrical and electronics engineering. It also provides the premier interdisciplinary and multidisciplinary forum for researcher, educator, and concerned practical challenges encountered and the solution adopted in the result. Now, we would now start the oral presentation. However, due to paucity of the time, we would request the speaker to please limit their respective presentation within 7 minutes. Out of the 7 minutes, 5 minutes for oral presentation and 2 minutes for the discussion. So, all the participants are requested, kindly make a note of it. So it's time for student presentation on emerging trend and new technologies in electrical and electronics engineering. I would like to call Ms. Kritika and group for oral presentation, and her topic is IoT based transform monitoring system using Node MCU. Kritika, please.
Good afternoon to one and all present over here. As we know that we have gathered here for the third international conference on recent trends in renewable energy and sustainable development. So I am here, Kritika Panigrai, student of 8th SEM EEE department, along with my groupmate Aniket Chavlani, presenting on the topic IoT-based transformer monitoring system using Node MCU, and our supervisor has been Professor Abhishek Kumar Sahu, sir, HOD EEE department, BIT Raipur. This is basically the roadmap: abstract, methodology, assembly, installation, conclusion and future scope, and at the end, references. Next. Next. So, transformers are the main building block in a power system. Working condition of transformers plays a vital role in the distribution network, and any damage in them adversely affects the balance of the power system. Damages occur due to overcurrent, overvoltage, fluctuation in oil level, which can cause deficient cooling, and this all can cause unexpected failure. So its manual checkup is not possible at all the time. So for this is the IoT based system which will help in monitoring all these parameters and help in identifying the fault before any such failure happens. Next. This is basically the flow chart. Like you can see the starting point, then sensories are installed, sensories are connected to the transformer, and the sensories that are sensor A, B, and C may be variably like voltage, current, temperature, oil, etc. All the sensors. That will be done processing in the microcontroller, and then the values will be displayed in the LCD. That is, LCD screen may be mobile, laptop, your personal computer, etc. And at the end of this flow chart. Next. These are the components used, that is voltage sensor, current sensor, temperature sensor, and this is a transformer. The transformer is of small value because we used it for a compact. Next. Methodology. Methodology. This basically contains that transformer is directly connected to all these sensors. These sensors are voltage sensor, temperature sensor, current sensor, oil level sensors, and some base frequency sensors can also be used, but we didn't use it in our project. And all these sensors are connected through microcontroller, that is basically Node MCU. Node MCU is an open source IoT platform, and this Node MCU is then connected to the mobile in which the values will be displayed. Next. Methodology point. This basically is the methodology point that all these components are connected, like voltage and all the sensors are connected to the transformer. This transformer is connected, then the sensors are connected to the ADC, that is analog to digital converter. All this analog to digital converter is connected to Node MCU. Then the Node MCU is connected to the screen, that is the mobile or the laptop or the PC screen, and the system basically indicates the fluctuation in all these values, that is voltage, current. Somewhat if they are fluctuating or they are rapidly increasing, then the user can be informed that this is rapidly increasing and an unexpected failure can be avoided. Next. Node MCU coding. So Node MCU coding, we basically did it in a C language. This code has basically a loop. Like sometimes what happens, then we are near the transformer, any human hand is near the transformer, then a loop will be generated because due to that hand, somewhat a rise in temperature might have happened. So this sudden rise will not cause any effect on the transformer or in the rating. So a loop is generated in this code, and this is basically a C language, the most easily available language through which the Node MCU is coded. Next. So see, the code has been written in Arduino IDE platform. Necessary libraries, pins were used and pins were initialized. And see that I have said a program loop is executed wherever human hand is kept under 15 centimeter distance from the sensor digit pins, and the pin 4 of the Node MCU will get high and a loop will be created, and again from 0 all the sensors value will be noted. Next. Next. See, all the sensors, that is voltage, current, etc. sensors take the value in analog form. So for that ADC is used, analog to digital converter, because Node MCU can be fed only digital values. So ADC is used, and then multiplexed values are fed to the Node MCU. Basically, there is an app called Blink app. It is a very user-friendly app. We have to install that app in the mobile phone. Next. So for this, what we did, we could not exactly measure the temperature. So for this, we used 3 bulbs and gave a voltage of 5 volt. When we lighted the first bulb, there will be no any the fluctuation. But after lighting all the 3 bulbs, there will be increase in the temperature. This will cause a fluctuation in the temperature sensor. Next. So basically, next. So this project is user friendly. A man can be installed. It can also give an opportunity regarding job. A man can be installed at basically many big firms where transformers are used, and transformers burning can be avoided by measuring all these values. And this study will obviously help in cost minimization and reducing the workforce in maintenance. Thank you. Any queries?
Next speaker.
Model switch. Thank you, Kritika. We appreciate your hard work and wish you a very great future ahead. Now, I would like to call our next researcher, Dr. Devanand Bhosle. He is Senior Assistant Professor from SSPC Bhilai. For oral presentation, his topic is medical image and its application in field of medical science.
Hello.
Yes, you are audible and visible. Please.
Okay. Good afternoon, all the dignitaries present over here and dear participants. I'm Devanand Bhosle, going to give my oral presentation, and my topic is medical images and its application in the field of medical science. Next. This is the outline of my presentation. First of all, I will introduce the topic and different types of images. Then what would be the research objective for doing this research? And then after, I will actually going to explain medical images and their application in our medical purposes. Then after conclusion and various references taken to understand this topic. Next. So we all know that digital imaging is nowadays, it is very important in our day-to-day life, such as we use it for the normal images, and we all are having the camera. So that's why we are having the idea about different types of images. But in most of the application, we use it called as the reinforcement, remote sensing. Sometimes we use it for the forensic applications and the satellite imaging. But the most important field is called the medicine, where we get different types of imaging. And here I just showed total 5 types of imaging techniques. First, you can see in the leftmost, that is called as the computer tomography images. Generally, we know it as the CT scan images. Second is called as MRI, that is the magnetic resonant images. Third is called as the X-ray. This is the chest X-ray. However, we can take different types of images using X-ray. Fourth one is the positron emission tomography images. It is called as PET images. And last is called as the ultrasound images. Next. So my research objective to write this particular research paper is the usefulness, to understand the usefulness of various types of medical images. and to understand the acquisition process of the medical images. It is not that much easy. That's why it requires different types of imaging techniques. And sometimes the doctors or radiologist or physiotherapist refers us to go for the particular imaging system. So we will try to understand what is the different types of acquisition process and imaging system. And third point is that the noise signal corrupts this type of medical images, which is the severe problem, and we try to understand what are those type of images which corrupts our imaging systems. Okay, now the last point is that there are different types of filters available to suppress this type of signals. Next. As per I already explained in my first slide that different types of imaging techniques are there. So X-ray, CT scan images, MRI, ultrasound, and PET images. If we will talk about X-ray images, so there are different types of application. We will see in our next slide. Next, please. Next. You can see in this particular slide that these three images, whether they are the CT, actually the two are the CT images and last one is called as the ultrasound images. CT images are generally affected by additive white Gaussian noise. This is a noise which is available in almost every frequency domain. So this is the noise. This is the universal noise. You can see in its effect, which is continuously added up with all the pixel values and corrupt it seriously. In the second image, we can see that is called as the salt and pepper noise. This is called as so because it is white and black grains, which affects the particular pixels, not all the pixels. Now, in the third imaging, this is the ultrasound images, and they are corrupted by speckle noise, which is multiplicative in nature. Next. Now, here I tried to explain different types of noise signals. Gaussian noise is additive in nature, salt and pepper is impulsive, and speckle noise is multiplicative. It means that if a particular noise signal affect a particular image, so if it is added up with the pixel values, so this is called as the additive noise. Gaussian noise is the example of additive noise. If we will talk about the salt and pepper noise, this is not the general noise, but it is the problem which occurs due to any transmission problem, or sometimes it is just because of the black spots. And a speckle noise is called as the multiplicative noise. This is multiplied with the pixel values, and this generally does not introduce in all types of images, but it is due to the diffraction while taking the ultrasound imaging technique. Now I explained these type of noise signals in the various parameters, and you in the last row you can see the probability density function of these noise signals. Gaussian noise is having the bell shape. That's why this is called as Gaussian, and the salt and pepper noise is the spike. That's why it will be having a particular values. Next. Hello. Okay. Now here I'm going to explain the different types of applications. If you will talk about X-ray images, we all are aware of this X-ray. Sometimes it is having the problem of the any kind of injury, like bone fracture and all. We use it, but in the last year, we all are affected by the COVID-19, and most of the time we saw different types of the X-ray images that is called as the chest X-ray. It is spotted the pneumonia. Next. CT scan images are generally used to diagnose the muscle and bone disorder and bone tumor and fracture. Sometimes it is also used to detect the infected blood clots in our body, and sometimes it is used to monitor the heart, lung, and liver. Next. Now, the third is called as the MRI images. If sometimes there is a problem in the brain or spinal cord, so doctor suggests this MRI. This is very costly. You can say this is the most costly imaging technique in the medicine field, and it is generally used to check the abnormality in the joints in the back or knee. Next. Now, the last is called as the ultrasound images, and this is the portable device which its cost is also very less, and it is generally used in two cases. First of all, if there would be any problem in our soft tissues like stomach and all, so doctor prefer us to go for the ultrasound images, and the most important application of this ultrasound image is to examine the unborn child fetus in the pregnant woman, and it is also used for the different types of anomaly test in the unborn child. Next. This is called as the PET images. This is not very familiar to all of the person because this is nothing but the topic of the radioactivity medicine. It is used for, this is the full form of PET is the positron emitted tomography images, and it is used to check the cancer or evaluation of the cancer treatment. It is also used to see different types of disease in the whole body. So you can say the PET images are used for the whole body checkup. If there would be any infection or any other anomaly in the body, we use PET images. Next. Here I'm going to conclude with all types of imaging technique, since the time is very less, so that's why I'm not going to explain the hybrid imaging techniques. We have done research in this particular area, and we have hybridized different types of images to improve the quality of the images. And our research area was the denoising of this type of imaging techniques. So you can understand that medical imaging are used in different types of fields, and the objective of writing this research paper is to give a platform to all types of imaging techniques with its functionality, what are the types of problems to retrieve this type of imaging and all. So here I can conclude that it requires a complex setup, and it charges very more, and we do not use it frequently in our day-to-day life, but we use it in the rare condition. It needs expert. No one can directly diagnose all type of imaging technique, but it needs experts called radiologists and physicists. It is affected by different types of noise signal we have already discussed in our previous slides, and there are different types of various techniques which are called as the wavelet transformation, bilateral filter, then MMWF, median filter, and all. So the most important thing is to retain the edges, ridges, and fine structure of these type of imaging technique, and they are used to diagnose the anomalies over the body. So that's why if we will go for any imaging technique, these are not safe sometimes, because X-ray can be the reason of the body cancer. So that's why only in the extreme condition we go for this type of imaging technique. And I can say that there are new technologies to make the system more and more advanced nowadays. So I can say medical imaging is the pivotal, plays a pivotal role in the medical science. Thank you. Any query? These all are the references I have taken.
Thank you very much, sir, for your nice presentation. I have one question.
Thank you, sir.
More beneficial for medical imaging, sir? Is it X-ray or CT scan or MRI? Which technique?
Excuse me, sir. Sir, could you please repeat it again?
Okay. Which technique is more beneficial for medical imaging?
Sir, actually, these all are plays important role in their own particular area. You cannot take the ultrasound for the bones. You cannot take the X-ray. You cannot take the X-ray for the brain. So that's why for different parts. Actually, this is the huge topic, sir. And many researches have been done. Only the problem is that you cannot say one is the universal method. So you have to use for different purpose. And what we do, my research topic is that we particular hybridize this type of imaging techniques such as CT scan images and MRI. So we get the other type of imaging technique. So we are doing research in this particular area also. But sir, this is the beyond of this presentation. So that's why I'm not going to explain here. But if you want to know that which is the best, no one is sir least, but all are best in their own area.
And one suggestion is that you can add the UCL technique, that is called upconversion luminescent technique for medical imaging. That is the latest technique. Okay.
Okay.
So you can you can add and you can research in this area.
Sure, sir.
Very nice.
Okay. Thank you. Thank you, sir.
Rashmi ma'am, please. Rashmi ma'am, please move forward.
Hello. Thank you very much, sir, for sharing your respective knowledge with us. Now, this is the time to encourage the spirit of our next researchers. For that, I would like to invite Fareen Karnoje for her presentation, and her topic is Design and Implementation of Energy Consumption Information System using GSM.
Good afternoon all. We are from Anjuman College of Engineering and Technology, Nagpur. We are from Electrical Engineering Department. The title of our project is Design and Implementation of Energy Consumption Information System using GSM. The author of our paper is Dr. Ruhi Uzma Sheikh. The project member of our group are Fareen Kanoje, Asavari Jumnake, Pratiksha Bhoyer, Rishika Bodele, Arya Ingle, Vaishnavi Sirsagar. Next. Overview of our presentation is introduction, objectives, literature review, methodology, block diagram and working, references, conclusion. Next. Introduction. Different types of technologies are developed which are used to measure the electrical power consumption. In Maharashtra, most of residences use an electromechanical wattmeter. But in this device, the readings are not automated. And to pay the bill, the user has to wait a month. At the end of month, any member from the staff of Mahavitran visit at every house to read the meter reading, and at the same time they give the electricity bill to the user. This means that the electromechanical wattmeter does not show that how many units are being consumed in a day. Next. Objectives. It's aimed to design a circuit which helps the consumer to monitor the electrical energy consumption and protect him or her from the extra charges incurred due to minor changes in slab. Even small changes can affect the bill at the high rate. It implements smart energy and billing, which will go a long way in making consumer conscious about the amount of energy used in a more economical. Next. Literature review. Author B. Preeti G. Arish. Technology, design and implementation of smart energy meter work. This is implemented to getting a fully automated electricity billing system. The aim is to measure and monitor the electricity consumed by consumers in a locality and transmitting the consumed power to the station. Author P. Amrita. Technology, electricity uses, monitoring and alerting system work. Electricity is one of the unavoidable sources of energy in our day-to-day life.
In block diagram, power supply is used, Arduino Nano is used, 16:2 LCD display is used, current sensor, voltage sensor, GSM module and mobile phone. Next slide. Methodology. In this project, Arduino and GSM technology is used to implement the entire concept of the smart energy metering and billing system. The main component of this project is Arduino Nano. Take a reading from the energy meter and sends it to the GSM module. A SIM card enabled GSM module is used to communicate to users. There is no rotating part in the energy meter system. The microcontroller system continuously record the reading and the live meter reading to the users via SMS. When the load is switched on, Arduino is ready to sense the current and voltage value through the current transformer and voltage. Every second, microcontroller senses the power. Next slide. Next. Next. This is PCB design of hardware module and this is circuit diagram of hardware. PCB design of actual material, procuring of material, layout of PCB, preparation of PCB, assembling of component and testing. This is flowchart. Next. This is our project hardware model and alert SMS. Next. Conclusion. A home load management system for distribution utilizing to prevent unnecessary load shedding during peak hour is proposed in the research. The use of GSM communication technology helps lower the expense of the system and the interaction of the respective system installation. It is not only benefit the consumer, it is also benefit the government since it helps in reducing the power consumption and which automatically can reduce the unusual power uses. Next. These are the reference. Thank you.
Hello. Yeah, I do have some questions for you. What is the current rating model you have used? Means the current sensor you have used, what is the rating of that? Am I audible? Fareen? The current sensor you have used, what is the rating of that? This is my question.
Hello, your audio is not clear.
Hello.
So 5
My
ampere
question
rating is
that
used.
what is the
5
current
ampere
rating of
current
your
sensor.
current sensor? I mean to say, how much value of current it can measure?
So up to 5 ampere.
5 ampere. Okay. So you have used that ACS model?
Yes, sir.
ACS 05B, I think so, right?
Yes, sir.
Okay, okay. And what about voltage sensor? You have made your own voltage sensor or you have brought the ready-made model for that?
Sir, we have used a different component of voltage sensor, that is ZMPT.
Okay, okay. And what is the algorithm for power calculation?
Sir, it is directly in programming, of which we are using as Arduino, and we are the programming only the calculations are calculated using VI. Power is equals to VI, that is apparent power.
Thank you, Fareen. We appreciate your hard work and wish you a very great future ahead. Now, this is the time to encourage the spirit of our next researcher. For that, I would like to invite Vivek Kumar Bharti for oral presentation, and his topic is vertical axis wind turbine for highway.
Good afternoon, everyone. This side Vivek, and our topic is vertical axis wind turbine for highways. Next slide, please. So, why do we choose this topic, and why we are using vertical axis wind turbine? And there are some causes which we need to feel with this vertical axis wind turbine, like the supply is decreasing day by day of coal and petroleum, which are the primarily sources of electricity. And moreover, the demand is increasing, and as the demand is increasing, the consequences like the extra fuel and the consequences of coal and petroleum is increasing. So to decrease this type of consequences and using another renewable sources, so we are working on a vertical axis wind turbine, and it will be installed on highway. Next slide, please. So our objective is to create a suitable non-conventional energy sources and helping highways to depend its on energy sources. According to a survey, in India only, the around 3,420 million kilowatts is used to for street lights, which can be decreased by using our model, which is a vertical axis wind turbine for highways. Next slide, please. So actually, from our childhood days, we have seen that there are various types of wind turbines. One of the most common wind turbine is horizontal axis wind turbine, but why we are not using over here because of the high maintenance required in horizontal axis wind turbine, and the consequences of that, like many birds dies due to horizontal axis wind turbine, and maintenance is high, and moreover there is a high chances of accidents, like whenever the wind blows above the rated speed, there are high chances that horizontal axis wind turbine might fall or get damaged, or their wings get damaged, and this all problems are resolved by the vertical axis wind turbine, which we are using in our project. Next slide, please. What are the advantages of our disadvantages of horizontal axis wind turbine? There are some displayed, like in horizontal axis wind turbine, the rotating axis is parallel to the direction of wind, and the main motor shaft run horizontally, and the rotor or the rotor faces the maximum kinetic energy of the wind, which is not an efficient way to absorb the energy in it. And so what are the disadvantages of vertical axis wind turbine? That the maintenance is high, as previously I have told. So here's the basic comparison between horizontal axis wind turbine and vertical axis wind turbine. Next slide, please. So the basic block diagram of our model. So actually what happened, whenever a vehicle passes over a lane or from road or highways, it displays a wind which is present at that place, and whenever the vehicle is speed at a 40 km per hour or 60 km per hour, the wind is displaced and move towards left side and right side. So that movement of wind is captured and is turned into a mechanical energy by your rotating shaft, and then with the rotating shaft rotating mechanism, that energy is further converted during this. There is a particular defined definition that in ambient condition there is another motor working, and in high speed wind there will be another motor working. So in ambient condition there is a normal alternator, and during the high speed wind there will be a high torque DC motor, and further this alternator and DC motors will produce energy, and which will be stored in a battery. Next slide, please. So this is our basic model. I would like to request to play this. It's a sample, like in it's the highway, two-lane highway, and in the center there is a shaft and the mechanism is attached to it, which rotates whenever a highway crosses over it there. Ma'am, next slide, please. So as we have designed this mechanism and tested our highways, and there are some relation between speed and the power. As the speed increases, the wind speed increases, the power also increases. But at some point where we can get the maximum power and speed. That's approximately around the velocity is about 1 meter per second, 30 meter per second, and the power is generated over 1 watt per 30 meter per second of wind. Next slide. So this is basically a graph between the power produced, the voltage produced, and the current produced. We have checked using the voltmeter and ammeter. And as we can see, the average power output will be around 6 watt, and the wind speed average is 9 meter per second, and the current will be too low as the voltage is high. Next slide, please. So we are moving towards the calculation. So the calculation is the mass which will be replacing is equal to rho into area into volume. Area is the area of our panel which will going to displace the wind, and further the kinetic energy, like there is a law of conservation of energy. So the wind energy will be converted into kinetic energy, and the kinetic energy is further converted into mechanical energy. So the basic calculation of kinetic energy is equal to half mv square. So here the mass is a rho density of air, area into volume. So the mass becomes rho av, and a half into mv square. So v is the velocity into v square. So it's becoming v cube. And here we'll be using a Bell's limit, which is 0.593, which is maximum power coefficient. Like we can means the maximum efficiency of a power where we can use. Next slide, please. So the power output, the average power output we have taken out, which is 166 watts above calculation. Considering our blade size is 80 centimeter is to 30 centimeter, and diameter is of 1 meter. Next slide, please. Hello, ma'am. Next slide, please. So this is a working model, which is of 20 centimeters to 80 centimeter dimension of blade, and the gear ratio is kept 1:10 for the smooth performance of our DC motors, so that there will no high load on a motor, and further it can rotate and build DC electricity. Next slide, please. So these are the relation between the wind speed and the RPM, blade angle, and what should be the blade angle and what should be the wind speed. So as we can see over here that the revolution per minute and the blade angle is at what angle the revolution will be high, and at what angle the revolution, according to our calculation, the best blade angle is 11.22 degree at a wind speed RPM should be 80 revolution per minute. Next slide, please. This is the so again here is the power and the RPM relationship, and this is between our DC motors and the power output produced by the motor. Next slide, please, ma'am. So here comes the cut-in and cut-off speed. The minimum speed to run our equipment is 1.27 meter per second. This is the minimum speed on which our instrument will work. Either we can install it on the highways or besides of railway tracks. And the cutout speed means this is the minimum speed, maximum speed at which the efficiency of our equipment will be the best, which is 7.8 meter per second, and which will be approximately 8 meters. And after this speed, there will be no advantages of means as the speed increases, there will be no more power produced. So the safe side will be the approximately 8 meter per second of the wind. Next slide, please, ma'am. Going towards the future scope, this model can work like 24 into 7 to 365 days, because all over the days the vehicle travels each day, because without vehicles life become very messy, and it's moreover it's the noise free. So we can further work on it to become a noise free, like using good bearing system and making it for a workplace or a home by using good ratio system and a good DC motor. And this is only. And next slide, please, ma'am. What will the cost estimate of per model, which is around 6,000 rupees, and it's basically it's a mid-sized model of 27 centimeters to 80 centimeter, and we can further enlarge it, this model, for the good power output and efficiencies. Next slide, please, ma'am. These are the references we are used for our research work and paperwork. Next slide, ma'am. Thank you, sir. Thank you, ma'am. Any queries, sir?
It's time to solve your queries. If anyone will be having some...
Ma'am, not clearly audible.
If anyone will be having some questions in their mind, so you can ask. No? Thank you, Vivek. BIT Raipur wishes you a very glittering future in the Department of Research and Development. Now, this is the time to share the strength of the next researcher. For that, I would like to invite Yashwant Agrawal, and his topic for oral presentation is IoT-based water level monitoring and automation system using Node MCU. Yashwant.
Good afternoon, everyone present here. Myself, Yashwant Agrawal from EEE Department, student of BIT Raipur. Next. So here I'm going to present my topic: IoT-based water level monitoring and automation system using Node MCU. This is the route map which I followed. So first of all. First start with the abstract part. Nowadays, people want everything is happen in more smarter, more easier and more efficient way than the older technique. So from this, we can monitor the water level of water tank from our smartphone by installing a simple circuit inside the tank and installing an application in the smartphone. We can So introduction part. As we are aware about, water resource is one of the most precious and important resource in our daily life. But knowingly and unknowingly, we are wasting water by manually or leakage or overload and unnecessary open tap, which rise the wasting water level. To avoid all those defects from older techniques, here we are using the technology called Internet of Things or IoT, which because IoT is defined as everyday things get connected for a smarter tomorrow. So here I am going to explain my methodology. Next. So according to the previous problem, the new system needed are followed. System to update the real-time waste water level, device to monitor the level and control the device from the previous device. So this is the flow chart, how the system works. Here is a ultrasonic sensor installed inside the water tank, and ultrasonic sensor sense the real water level and give this information to the Node MCU microcontroller. Microcontrollers upload the information to the web servers, and web server gives the information to the smartphone application. And if a condition comes that the tank was empty, the Node MCU give the notification to the user that the tank is empty. and node MCU fill the tank itself. This is the hardware requirement list to build the project. Next. This is a circuit diagram to build the project. So here we see in the left hand side there is a interface of app, how the water level really shows in the application. In middle you can see the circuitry part of the application, and in last there is a notification how the shows by the app that tank is empty. So let's talk about the benefits of this. Next. First, it is cost efficient. It is very cheaper in rate. Second, it is user friendly and easy to use. Next. It is very accurate as compared to the current technology, and it consumes less power. Next. Now let's move to the conclusion part. Next. It is an IoT-based water level monitoring and automation system. We can monitor and analyze the water level of tank by an application called Blink. If the tank is empty, then it can automatically turn on the water pump if the water was coming through the pipeline and give the notification to the user's phone. Next. So, have you have any query?
Good morning. Good morning. I wanted to ask which board have you used?
Sorry?
Which board have you used for the connection?
Sorry?
Which board had you used for the connection?
Which app?
Board.
Board.
Yes.
I use the Node MCU. The model number is ESP8266.
I wanted to ask which application.
Thank you, Yashwant. BIT Raipur wishes you a very dazzling future in the Department of Research and Development. Now, it's time to give chance to the emerging researchers for oral presentation. For that, I would like to invite Sahil Sheikh and group, and their topic is car parking system using cloud computing and Android application. Sahil Sheikh and group. Sahil Sheikh and group, may I audible? Okay, now this is the time to encourage the spirit of our next researcher. For that, I would like to invite Abhishek Singh, and his topic is gyroscope with Internet of Things.
Good afternoon, everyone. I'm Abhishek Singh here to give a presentation on the topic of gyroscope with IoT. So let's start. This is the route map we have to follow. Next. Here's the some abstract. Gyroscope is a microelectronical mechanical system. And after we have using the IoT, it increase the efficiency of the gyroscope. No manual operation is needed. And it's work with parallel with the gravity. Next. Introduction. Basically, gyroscope is the device which used to balance the unbalanced object or body with the comparison with the gravity. Next. Procedure. In this project, we connect the gyroscope with the IoT with the help of MPU 6050 sensor, which sends all the 6 axes, and ESP8266 module to connect the system with the internet. Next. Benefits. There is no human interaction. The user can monitor each and every detail, high-level accuracy, compact in space. Here you can see how our project is work. Basically, there was an unbalanced condition. MPU 6050 modules read the unbalanced condition and send the data to the Arduino. Arduino process that data and set that to the motor. Motor will balance the condition with the help of the gyro wheel. After that, Arduino send the command to ESP8266 module. With the help of 8266 module, user can find out what happened at the object. Next. Conclusion. Basically, the system is fully automatically, and because of the automated, we can use the two-wheeler to reduce the accident at the roadside. Whenever the system gets unbalanced, it activates the gyro wheel and make the object or vehicles at the balance condition. Here are some references we have taken from the internet and other things. Thank you. Have any queries? Thank you.
Thank you, Abhishek. We appreciate your hard work and wish you a very great future ahead. Now, this time to share the strength of our next researcher. For that, I would like to invite Sahil Sheikh and group. And their topic is car parking system using cloud computing and Android application. Sahil Sheikh.
Yes, ma'am. Ma'am, am I audible? Okay. Good afternoon.
Sahil Sheikh.
Good afternoon, all.
Am I audible?
Yes, ma'am. Yes,
Yeah.
ma'am.
Okay, start.
Good afternoon, all. My name is Sahil Sheikh, and today we are going to present a small project structure of our project, which is car parking system using cloud computing and Android, application. Here is our group members: Sweetie Gonde, Aishwarya Lakhe, Yash Deshpasar, Arish Pathan, Uwais Pathan, and I'm Sahil Sheikh. And our project guide is Dr. Ruhi Uzma Sheikh, and the co-guide is Professor Ishraq Ahmed. They both are from electrical department from Anjuman College of Engineering and Technology. Next. So basically, how many times that will happen with you that you went somewhere and parked your vehicle, but you didn't found any place to park your vehicle. Like if you went somewhere and you don't found any place to park your vehicle, so you have to shift to the next place, like which may be around 1 or 2 kilometers away from that previous place. So that waste your time to park a simple vehicle, right? So basically, we found that this is basically a flaw in the parking management system. So we have come up with the idea to make an IoT based application and a project which basically tell user and a driver where is the best place or the perfect place to park your vehicle. So we have developed some IoT devices like using ESP12 chip, which connected with the sensors, and also developed an Android application with respect to that project ESP12 chip, and which basically sense the parking slot is which is available to park or not, or reserved or not, and tells upload their data on the cloud server, which we use for Google Firebase cloud server. And using the Android application, we can see the which is a place where parking slot is available or not. Next. So these are the components which we are used in this system. So basically our aim is to make this project cheaper, so everyone can install this system in their buildings, in the malls, in any places where they want. So we have used ESP12 chip, ultrasonic sensors, power adapter of course, and the light indicator light kit, and the relays. Basically ESP12 chip contains all the coding part which uploads the sensors, ultrasonic sensors data on the cloud server, and power adapter is to use to give the power to the ESP12 module chip and the ultrasonic sensor. Also the light indicators are used to indicate the parking status on site where the electronic components are installed. Also relays are used for the protective system. Next. So tools and software that we are used to build our Android application and code are the, first of all, we have used Android platform, as the many, like 80 to 85% of the users in India usually use Android devices. That's why we have implemented this project on Android platform. And for develop an Android application, we have used Android Studio IDE, which is the integrated development environment, and Arduino IDE to upload the code on ESP12 module. And to control the version, for example, if you are upgrading from version 1 to version 2, we have used GitHub to control the versions of the applications. And for the database and cloud, we have used Google Firebase cloud services, which is the reason why we use Google Firebase cloud services is because they are cheap and we don't have to store the much bulk amount of data. And if we use our separated database or separated dedicated server, then it costs a lot. That's why we use Google Firebase server that provide us 5 GB of the data, which is more than sufficient for a unit of 100 parking areas. And for the programming language, we have used Java to code Android application, and C++, C and C++ for the it's C programming language for to code the ESP12 chip. Next. So basically this is our block diagram, which is showing how the working is happening for the project. So basically we are providing the power using power supply, and the power control unit controls the power, which it converts the 240 volts to 5 volt for the microcontroller or the ESP12 chip. And then ESP12 chip itself, it contains the Wi-Fi module, so it sends the data which is from the ultrasonic sensor which is installed at the parking system, and it took the data from the ultrasonic sensor and upload on the Google Firebase cloud server. And after the uploadation, we can use our Android application to check whether the parking is available or not. Also, we can use a display screen if we are on a spot, like if we are already on the site where parking system is installed, then you can use a display screen to check whether which parking slot is available or not. Next. So where we can, these are the applications for where we can use this system. Like we can use this system at malls, at offices, as residential apartments, at government places, at etc. So this is a quite, which are this project we are implementing in our college, in our engineering college, for testing purpose. And after some upgradation, we can use this project for security purpose also. For example, we are about to add one more functionality in this project, like if a person park their car at some place, then this system can track the user's identity as well as the parking car identity using the tracking GPS system. And if someone stole the user's or the owner's car keys and stole the car, then it can easily track the thief using the location tracking module system. So this can improve the security of the parking places. So, yes, so that's all from our side. Next. Thank you so much. If you have any query, then you can ask.
Participants, if you have anyone queries.
So thank you so much.
Thank you, Sahil. We appreciate your hard work and wish you a great future ahead. Now, this time to give chance to the emerging researcher for oral presentation. For that, I would like to invite Rimjim Pandey and group, and their topic is an overview on treatment of sewage residual and sludge. Rimjim.
Good afternoon. Am I audible?
Yes, please.
Good afternoon, all the dignitaries present here. Myself, Rimjim Pandey, an undergraduate student.
Am I audible?
Yes, ma'am. Ma'am, I am present in the Google Meet.
Please continue.
Myself, Rimjim Pandey. I am an undergraduate student from Sri Shankaracharya Technical Campus, Bhilai, Chhattisgarh. Speaking in front of you, my topic is treatment of sewage residual and sludge. Today, I am here to enlighten a very strong issue that is faced by everyone, but still undergoes unnoticed, and we aren't much aware of that. Today, my duty is to pay attention and make you feel attentive towards the topic, and the slide goes like this. Next. The outline of my presentation goes, first, I will give the introduction, then I will tell the objective and the problem which we are facing and the solution which I came across and the conclusion, and finally the reference where I took the reference. Next. So the research objective is that to protect the environment, social, economic and public health from pollutants. And second, to remove as much as pollutants, toxics and suspended solids as possible before the remaining water is discharged back to the environment. Third, to preserve water quality of natural water resource, to prevent the spread of harmful diseases in the surrounding locality. Next. As we can see that sewage look like this, and they are very harmful, and there are very harmful residuals present in the sewage water, and these are known as sludge. Toxins from soils and waters, which include heavy metals and radioactive contaminants, these can harm us and our locality too, such as plants, environment, and all the things that are very important for our Mother Earth. Next. As we all know the term sewage water treatment, from the term sewage water treatment, we understand that it aims to remove contaminants in the water from nearby industries. In Chhattisgarh, we have very big industry like Bhilai steel plant, and this can harm the surrounding from where we live. The residential areas are very polluted with air pollutions and water pollutions in the sewage water. The main focus of us is water pollution. Next. As you can see that there are various pollutions that are occurring from the Bhilai steel plant. So to reduce this, we use some organic methods. Next. Organic methods such as planting trees and plants such as these plants are known as hyperaccumulators, and these are used to remove the water impurities from the soil, and this is very efficient and also a less cost method. So we can use this to prevent the soil also and to maintain the water quality of the surrounding. Next. So the solution is we can use to filter those residual and sludge. We can use organic processes such as planting some plants which can help in purification of sewage water. These plants are known as hyperaccumulator, as I said, which absorbs high level of pollutants without being poisoned themselves. They take up toxins from the soil and water, which include heavy metals and radioactive contaminants which come across in the industrial areas. These are easily affordable and hyperaccumulator plants under sewage water are. There are some examples such as duckweed, azolla, etc. And for terrestrial, beside the sewage water, we can use to plant sunflower, cabbage, and Indian mustards. Next. There are various inorganic methods, but these are also harmful ones. So avoiding these inorganic methods, we can switch to organic methods. As I already said, we can use those plantation, and this is very essential for our nature also. Next. These inorganic methods include addition of chemical substances in sewage water. Chemicals which are used for filtration of sewage water are chlorine, hyposodium chloride, aqua bleach, hydrogen peroxide, etc. These act as a disinfectant and assist the purification of sewage sludge contain heavy metals such as zinc, copper, nickel, lead, mercury, etc. Chemical precipitation, flotation, adsorption, ion exchange, and electrochemical decomposition are widely used conventional process for removal of heavy metals from sewage water. Thus, these are very costly methods. We can switch to organic methods too. Next. So the conclusion of this research is the sewage contains 99.9% of water and the remaining 0.1% is solid. To remove those solids, we can use organic as well as inorganic methods. Whereas organic methods are much efficient, whereas inorganic methods are these are costly also, and we should switch to organic parts. Next. These are the references where we took the reference for our research work. Next. I heartily thank all the organizing committee of VIT Raipur for giving me this wonderful opportunity to speak my research work on 3rd International Conference on Recent Trends in Renewable Energy and Sustainable Development. Thank you.
Thank you, Rimjim. We appreciate your hard work and wish you a very great future ahead. Now, I would like to call our next researcher, Mr. Yashraj Srivastav and group. For oral presentation, his topic is based on teaching and learning, an estimate of description of the current condition of a power system. Yashraj Srivastav.
Thank you, ma'am, for giving me this opportunity. So, is it visible? Hello. Is my screen visible? Okay. So good afternoon, everyone. I, Yashraj Srivastav from Kite Group of Institution, is going to present power system state estimation using particle form optimization. So basically, we have worked on taking the readings from the real time power systems, the past readings, and analyzing it by giving it wrong data, and then implementing it to see what was the exact reading of that power system. So these are the contents, introduction, and we have used two methods, WLS and WLAV, weighted least square method. So what are these two methods? Let's see. And there are some simulation results which we have used. So introduction of state estimation. State estimation is basically checking the past values and analyzing them to make the result better. So this is the diagram, state estimation diagram. State estimator, network topology processor, and these are the bad data processing and state variables which we have used. So method of state estimation, there are traditionally two methods, the weighted least square criterion and the weighted least absolute value criterion. And there are a few non-traditional methods like which are not used nowadays. PSOs and TLBO are currently used. So weighted least square method, in this method we have just taken a minimum variable, and in this method the variance is mainly used, which is, as we have shown, is equivalent to a maximum likelihood estimator if the measurement errors are modeled as random numbers having a normal distribution. These are the matrices which we have used, and the variance are used. And this is the flow chart. We just insert the wrong value in the measurement to check that the major value how it has deflected from the normal value. Matrix. Now this is the matrix flowchart of WLS method, and this is weighted least absolute value method. The same method, but here in this formula the minimum variable contains the standard deviation sigma i. In the WLS method we use sigma I square variance. And here we are formulating the problem using PSO, where there is a fitness function fx equals to jx plus px, and fx is considered as particle fitness function and jx is objective function. So this minimum value is for WLS sigma I square, and this minimum value is for WLV. There is a correction, sigma I, it is only sigma I, standard deviation in WLAV. And px is the penalty function, which is calculated using these formulas, and these are the constraints. Vi is fluctuating from minimum to maximum. Basic algorithm of PSO. Initialize the swarm from the solution space. Evaluate the fitness of each particle. Update individual and global. We can update the value by using that formula which I have showed, and velocity and position of each particle. Go to step 2 and repeat until termination condition. This is the flowchart of PSO. Start creating initial swarm of particles with random position and velocity. And the fx which I have showed earlier equals to jx plus px. If fx is less than fp best, then initialize p best with x1. And after repeating this procedure, we update the value of the readings which are shown and repeat this process until all the values are updated. Characteristics of PSO: simple implementation, derivative free, very few algorithm parameters, very efficient global search algorithm. This is the 6-bus measurement which we have used, and this is 14-bus. Simulation results are there for 6-bus. This is the graph. This is the comparison between true and estimative value for WLS, PSO WLS, and PLAV PSO, WLAV PSO. Statistical analysis for 6-bus. 14. This is the same, just 14-bus system is used. Future scope: power system estimation can be solved using hybrid model of PSO, and these are the references which we have used. Thank you, IIT Raipur, for giving me this opportunity.
Thank you. BIT Raipur wishes you a very dazzling future in the Department of Research and Development. Now it's time to give chance to the emerging researcher for oral presentation. For that, I would like to invite Yogita Sahu, and her topic is design and comparison of 50 kilowatt off-grid solar power plant and using PV system and PV solar.
Good afternoon to one and all present over here. My name is Yogita Sahu. I'm from EEE Department 8th SEM from Bhilai Institute of Technology, Raipur. My project is design and comparison of 50 kilowatt off-grid solar power plant using PV Syst and PV Sol, which was supervised by Professor Sunil Kumar. We all know that sun has enormous potential to meet global energy requirement. Then why its contribution is limited to 5 to 6% of total energy production? Do we ever think about that? Can anyone answer? Okay, the possible reason may be increasing. Okay, the possible reason may be increasing in PV penetration or technical problems such as improper selection of batteries or inverters, orientation or tilt angle. They may be one of the reasons leading to uncertainty in power generated, payback period or proper installation side. So what we can do for that? All we need is a tool that would provide a detailed analysis and report for a project before implementing it on site. This brought us to the tool named PV Syst and PV Sol. PV Syst and PV Sol both are simulation-based software. PV Syst was firstly designed in Geneva, which helps in designing of PV system. This enables us to calculate the amount of energy generated, estimated cost, and payback period. Likewise, PV Sol offers detailed configuration and shading analysis for PV system. Next, literature review. These are some of the literature survey for designing of PV solar panel using PV Syst and PV Sol. So here comes the proposed methodology. For designing using PV Syst, we have to first define the location of site, which can simply done by Google Map. By taking the information using Google Map, we can have the latitude and longitude of the site. Then next is defining a suitable PV module based on the consumption. The next is entering the meteor data. Meteor data include the orientation, tilt angle, and the time zone for a particular site. Next, we will calculate the losses of the system. After calculating the losses, here comes the simulation. By simulating, we will get to know about the losses in the system and the type of battery and inverter we need to design a particular system. These are some of the project images which I have designed using the software. For defining the field parameter, we have to keep the plane tilt. We have to adjust the plane tilt as such that the loss with respect to optimum should be 0% for effective designing of the system. This is the basic difference. This is the basic difference between PV-Syst and PV-Sol. Designing using both concludes that PV-Syst has an efficiency of 49%, while PV-Sol has an efficiency of 45% for 50 kilowatt solar power plant. Benefits implementing the proposed methodology. By designing using PV-Syst, we have following benefit. It reduces failure cost, it increases efficiency, we get perfect design, we'll be getting a proper exact payback period, and and it reduces the failure rate. So the conclusion of following project is PV-Sol is a software package with professional or its 3D version in premium. Environment and shading analysis shall be used only in building integrated PV system. It should not be carried out for a large designing system. While PV-Syst software package can be used for detailed design phase, when system components are going to be chosen for higher possible outcome. So in between PV-Syst and PV-Sol, PV-Syst is a more preferable software. Following are the future scope of a solar power plant. Many design projects has been proposed in India like Jawaharlal Nehru National Solar Mission, JNNSM, targeting 20,000 megawatt of solar energy by 2024. With continued technological advances, electricity prices do not increase through 2035. Employment in solar energy give many people the solar job. Expanding clean electricity supply yield deeper decarbonization. These are the references. Thank you. Any query?
Thank you, Yogita. We appreciate your hard work and wish you a great future ahead. Now, it's time to give chance to the emerging researcher for oral presentation. For that, I would like to invite Divya Singh. She is a student from BIT Raipur.
Good afternoon, everyone. I am Divya Singh of AAA department. and today I am going to give presentation on maglev elevator. So in this, we are going to cover all the several points. So now introducing maglev elevator, which is based on the concept of magnetic levitation. It is a method by which an object is suspended with no support other than magnetic field. Now moving towards proposed methodology. Maglev elevator is based on electromagnetic suspension, uses a maglev track in building which is embedded with coil to guide the cabins through a moving magnetic field. Now moving towards working principle. The principle of the motion is that there will be electromagnetic coils on the undercarriage of the elevator and also on the outer frame of the elevator. The coil attracts or repels, accumulating in motions. Conclusion of the topic is that it helps to move elevator in vertical as well as horizontal direction and increases capacity up to 50% since it allows more than 2 cabins per shaft. Thank you.
Thank you, Divya. BIT Raipur wish you a very glittering future in the Department of Research and Development. Now, I would like to call Saurav and group, and their topic is IoT-based charging system for LiPo batteries.
Hello. Good afternoon, one and all. Present here, my name is Subham Sinha from BIT Raipur 8th SEM EEE. My today's presentation topic is IoT-based charging system for LiPo batteries. The PPT consists of abstract, introduction, literature survey, followed by proposed methodology, requirements, benefit, result, future scope, conclusion. So our project basically designed for batteries charging with variable voltage and input, and also it consists of multiple charging, means number of ports are increased here. So next. Yeah, so our project consists of multiple variable. Yeah, it also consists of real-time battery monitoring system, adjusting and providing suitable current level for charging. Next. The literature survey consists of 6 papers. First is efficient battery monitoring system for e-vehicles, IoT-based intelligent smart control for electric vehicles. Next. Arduino-based platform for managing a PV battery charge, improved design of automatic car battery charging system. Next. Access charge controller using IoT. And last one is buck converter based battery charging controller for electric vehicles using modified. The proposed methodology consists of, this is the block diagram of our charging system. First, it consists of a basic AC to DC converter, followed by a regulator circuit to provide required voltage and current rating, and then the relay circuit, followed by the battery with BMS, and sensor, means current and voltage sensor are used here, and the IoT is done by using ESP module and Blink IoT app. Next. This is the charging process. First, we will select the port, then setting the required voltage and current, and next is microcontroller unit, followed by display parameter on LCD display, and last is command to charge. Next. This is the BMS process overall. First, setting of parameter. Next one is connecting the charge. Yeah. After connecting the port, we will compute the state variable of battery and sending the battery information to ESP8266 module. And last, it will collect the charging data from both charging and battery model. Next. The regulator circuit works by first DC input to rectifier circuit, followed by voltage setting and then current setting. Finally, it will send the signal to current sensor, microcontroller unit and relay circuit. Next. This is the regulator circuit we have designed here. It will provide variable voltage and variable current. Next. Next. Yeah, the hardware requirements are Arduino Uno, voltage sensor, relay module, transformer, current sensor, OLED display, and ESP8266 module. Next. These are the features of Arduino Uno current sensor. Yeah. The software we will use here is Arduino IDE. Benefits are multivariable battery charging, real-time power consumption display, parameter display over blink app, automatic current sensor calibration, followed by overcharge current cutoff, charging time estimation, reverse polarity protection. Next. This is the final output of our project. Here we can see that the voltage is shown in the Blink IoT app, which is 15 volt for port A, and port B is currently off, so it is showing off 0 volt. Next. Next. The future scope consists of we can increase the number of charging ports, overall rating can be increased, separate Android application can be also made here. GSM modem can be used to send data as an SMS because in the rural areas, the facility of internet connection is very weak. So by using mobile phones, data can be monitored even from remote locations. Next. So the conclusion is we can estimate charging time. There is no need to know the right voltage to current battery. Otherwise, it may slow down the charging. Required voltage and current is obtained here using potentiometer. And the communication of proposed hardware with Blink IoT is done by using ESP8266 module. Next. Yeah, so this is the reference. Next. If there is any query, you can ask. Thank you.
Thank you, Shubham. We appreciate your hard work and wish you a great future ahead. Now, I would like to call Shubham Sahu, and his topic is gesture control robot.
Thank you, ma'am. Thank you, ma'am. Good afternoon to everyone. Good afternoon to everyone. My name is Shubham Sahu from AAA branch, Bela Institute of Technology, Raipur. And today's my topic for my presentation is gesture control robot. Now, moving towards the introduction. Next. In this project, we are developing a combat robot which is fully controlled by the soldiers using the gesture control. Now, next. Here, for example, just suppose what will happen if we replace these robots, replace this soldier's body with the robotic body, and you can think what the soldier can do with having this robotic body. Now, moving towards the proposed methodology. In proposed methodology, we will first cover the gesture recognition. In gesture recognition refers to the processing of the digital image through the gesture recognition algorithm. Now, MediaPipe, it is a cross-platform through which we are going to use the gesture recognition system for our soldier so that he can control the robotic body. Now, the landmarks. In MediaPipe library, while he was capturing the motion, the MediaPipe library uses these 33 points from 0 to 32 for capturing the motion of the soldier. Next, towards the benefits after implementing this proposed methodology. Now the benefits are, the first, there is no need of any artificial intelligence. The second, the soldier will have same strength as much as of the robot. The third benefits is that there will be no casualties. And the fourth is the reaction type of the robot will be same as of the humans. Now moving towards the conclusion, as I have already told you that this robot doesn't have any artificial intelligence. It means that we doesn't have any danger by this robot. And the second is that we are using 3 different cameras for 3 different axes to capture the motion. Now the references. So references. So these are the references which I have taken for this project. Now, if you have any query, you can ask me. Thank you.
Thank you, Shubham. Thank you very much. We appreciate your hard work and wish you a great future ahead. Now, I would like to call Abhay.
Good afternoon, everyone. My name is Abhay Gautam. I am a student of Tripoli branch, Bhilai Institute of Technology. Today, I am here for give a presentation on a smart parking system, which is based on IoT. Today, we are talking about all these points. Now, introduction. In this project, we are making a smart parking system, which is based on Internet of Things technology, which will provide an efficient and smart way to automate the management of parking system. Now, my proposed methodology. In this methodology, the ultrasonic sensors will sense the availability of parking space and send those data to the processor. Processor will process that data and transmit it on the application. In this mobile application, users can have to book a parking slot and make payment. After completion of payment, those data will be transmitted to the cloud database and parking slot will be allotted to the user. Next, benefits. The benefits are of this system. This system will reduce the unnecessary traveling to find the parking space, and also it reduces the wastage of time. Now, conclusion. In the current world, where Google cars are introduced and automatic driving is growing interested among the pupils. This is an important of a great magnitude, and we will see that this project will provide a this project will add a value in urban lifestyle. Thank you.
Thank you, Abhay. BIT Raipur wish you a very dazzling future in the Department of Research and Development. Now I would like to call Rishika. She's a student from BIT Raipur.
Good afternoon, everyone. Myself, Rishika Kuldeep from second year EEE Department, BIT Raipur. I am here to present in front of all my topic, which is development of smart cities using IoT, a review. Next. In this presentation, you will go through these contents. Next. IoT is a rising technology which connects us with one another using a massive network of things. Here we'll only discuss about India and how we, the Indians, use IoT in our own way to solve our problems. Next. As such, there is no proper definition of a smart city because the goals can be different for different countries based on their development stage. Roughly, a smart city is a city that uses technology as solution to solve the city problems and provide a better quality of government service and citizen welfare. Next. Problems faced by regular city, urban sprawl, housing, overcrowding, unemployment, slums and squatter settlements, transport, water, sewerage problems, trash disposal, urban crimes, and problems of urban pollution. IoT. IoT is a technology which connects us with each other. It provides us with a unique identity and is equipped with ability to automatically transfer data. It does not need to have any human or human computer interaction to do so. This is the ideal model of a smart city. Thank you. Any queries?
Thank you, Rishika. Now I would like to call Shubham Singh for oral presentation.
Hello. Good morning, everyone, and welcome to my presentation. First of all, let me thank you for giving me this opportunity. I am from Electrical and Electronic branch, fourth sem, and my name is Shubham Singh, and my topic is street light monitoring using IoT. For this presentation, I am going to follow this route map introduction. In this presentation, I am presenting a model of a street light which is fully automated. We can detect whether the lights are defected or not and respond accordingly to that. And next is proposed methodology. A street light circuit is monitored with the help of say 800A module, which is going to track from the mobile or laptop. And next is benefit. It led to the reduction of energy and maintenance cost, increased public safety, safer traffic due to increased visibility of hazard and huge impact on the environment. And its conclusion. It clearly tackles major problems like energy wastage, crime detection, etc. Energy crisis reduced to 50 to 60%. Connection is reliable, established as soon as the system is powered. Or now future scope. There can be less light pollution and the power utilization. Reference. I have taken reference from these 3 research papers. Thank you.
Thank you, Shubham. Now I would like to call Shishir Verma and Tushar Kurre for oral presentation.
Good morning, respected teachers and Good morning, respected teachers and students. I, Shishir Verma, and my friend Tushar Gurre are here to give presentation on an IoT-based ESP 32 camera surveillance robot. So to start with introduction, we here have this project is usually made with the Arduino UNE board, and it is very effective for wireless communication from any part of the world where the internet reaches. As we know, in the today's world, robotics and artificial intelligence are used in at least every field. So next slide. So the hardware required for this project are DC motors, ESP32 camera, Arduino Uno controller, robot car chassis, a battery, and a TTL module. Next. छोड़ देना, एक और. So here is the proper working of the project. There is a IP address uploaded in the Arduino, which is then uploaded to any browser, which opens a portal from where which can real-time access and move the robot. So this kind of interface we get when after loading the IP address at the browser. So from here on, my partner Tushar will continue.
Good morning, respected teachers. I will proceed further. So here are some benefits of this surveillance car. First, to reach remote areas where human can't go and increase the human visibility. Second, the surveillance at night used for spying purpose, cost effective, sturdy, real-time video transmitting, surveillance of disaster affected areas to provide help. Next. Future scope. There are lots of improvement that can be made on the current design and technology. We can use different types of sensors like temperature sensor, motion sensor, pressure sensor, heat sensor. Next. Conclusion. The surveillance robot will be designed to deliver a reasonable level of efficiency and simplicity, providing each user with a streamlined user experience. The surveillance robot is aimed at providing monitoring inclusive of vision motion. Applications. The main application of these robots are we can easily monitor indoor as well as outdoors, reach congested places easily, used to record and share videos. These are resources from where we have taken the reference. Any queries? Thank you.
Now I would like to invite for oral presentation Manishwar Thakur. Over to you, sir.
Manishwar, you have only 5 minutes, na? Okay.
Okay. Well,
Yeah, you are audible. Please share your slide.
Yes, is it visible to you?
No, slide is not visible. Please share your slide.
It is. I'm sharing my. Is it visible?
So your
No.
presentation is not visible.
Should be visible. Just a second.
If you have technical problem, please resolve it. We will move forward to next invited technical talk.
Sir,
Yeah, Manishwar.
is it visible, sir? My screen is visible?
No, not visible.
Please wait, sir. Sir, the screen is showing, but not, it's not showing there.
You will share your presentation to me. In chat
Yes,
box,
sir.
I will my mail ID. Okay.
Okay, okay, please.
Ma'am, please move forward for invited technical talk by Dr. Salu Atri. Then after Maneshwar will be present. Okay, I have posted the mail ID in chat box. Please check, Maneshwar.
For a technical talk, I am delighted to invite Dr. Shalu Atri. Ma'am is Assistant Professor, Faculty of Science in Department of Chemistry, SGT University, Gurugram. We heartily welcome you, ma'am.
Am I audible now?
Yes, yes, please.
And my screen is visible? Okay, first of all, good afternoon to all of you, and I would like to thanks to giving me this opportunity. Today my presentation topic is potential of perovskite oxides in the field of catalysis. So before going in detail, first I would like to introduce with the term perovskite. These are the CaTiO3 kind of mineral structure and first time investigated in the Earl Mountain of Russia in 1839. And these minerals having the composition ABX3 type. In here, this A is alkali metal, alkaline earth metal ion sometimes it could be A3 goes to the transition metal ion with coordination number 12, and this B will be with 6 coordination number transition metal ion, and X is an ion here that can be oxygen, carbon, nitrogen, halogen, etc. Perovskite oxides are widely explored due to their structural accessibility. They can be transformed from one structure to another structure, and they are having various interesting properties due to their structures. The formation and stability of the perovskite depend on the size and charge of cations, that is tolerated by tolerance factor, that is TF, and the robust crystal structure associated with interesting physical and chemical properties is mainly responsible for their technological use. So if we talk about classification of perovskite oxides, then there are of 3 types, basically simple perovskite oxides, double perovskite oxides, and layered perovskite oxides. In case of simple perovskite oxides, if I talk about that, it will be AbO3 type of structure, and example is simple, that is cubic SrTiO3. This is the structure of simple this AbO3 perovskite, where this A is lying in the center of the cubic crystal lattice and B is occupying corner, and B is having coordination number 6 and A is with coordination number 12. So these are the possibility, like this octahedral position, this center corner of this cubic lattice can be occupied by these transition metal ions, and this A cation, this central cation could be all this alkaline earth metal and some other ions. So basically, this cubic structure can be converted into orthorhombic and this hexagonal structure based on their TF value, and this TF is the ratio of their ionic radii with the cations to anions ratio with this formula. So if this value lies in the range of 0.9 to 1, then the structure will be cubic. If it is less than 1, then it will be hexagonal, and more than 1, then it will be hexagonal or tetragonal symmetry. If this TF value is less than 1, then the structure will be transformed to orthorhombic structure, that will be distorted structure, that is CaTiO3 is an example. So simple perovskite oxides, they among these simple perovskite oxides, basically the rare containing this LiBO3 type of oxides, they are having interesting applications in electrocatalytic reactions. In case of double perovskite oxides are the oxides with the formula A2B2O6, and they can be ordered as well as random structured. They also have highest efficiency, electrocatalytic efficiency in the reactions. These oxides display significant role as electrocatalysts in oxygen. So different type of reactions they accompany in oxygen evolution reaction, oxygen reduction reaction, and hydrogen evolution reaction. These oxides should tunable band and behave as active catalyst in photochemical water splitting and CO2 reduction reactions, which is currently need of our society as well. These are some of the example of these oxygen deficient double perovskite oxides which are taking part in oxygen reduction reactions with high efficiency and high potential. The third part of this perovskite oxide is layered perovskite oxides, and these are again of three types: Dine-Jacobson, Rubelson-Popper, and Arrhenius oxides. So all these three type of oxide only differ by the interlayer part. They have the common perovskite slab. This term is common in all these three structures. They only differ by the interlayer part. Here it can be clearly seen that in case of Dine-Jacobson, these are the perovskite blocks. And these are interleaved by the cation. That is, here will be only one monovalent cation. In case of Rubelson-Popper oxide, there will be two monovalent, or it can be one divalent cation. But in case of Arrhenius phase, these perovskite blocks will be accompanied by Bi2O2 chain. There will be a chain between the perovskite blocks. So if we replace from one cation to another, these structure can be transformed from one structure to another structure. Like it is possible here to carry out Arrhenius to Rubelson-Popper conversion very well by etching or acid leaching treatment. All these three type of oxides can be prepared by employing these methodologies. There is a huge availability of methods, like in different morphology they can be synthesized, like in nanoform as well as in micromorphology. So sol gel, solothermal, and there are so many morphology. Based on the morphology, they can be prepared in nanosphere, nanotube, nanoplates, and nanowires. The remarkable feature of this perovskite oxide as catalyst is the main thing is their tunable electronic structure, redox behavior, and conducting properties of perovskite oxide. These are the remarkable feature of these oxides to behave as heterogeneous catalysts. A large number of useful physical and chemical properties of these perovskite oxides. Am I audible?
Yes, ma'am, you
Hello?
are audible.
Okay.
Yeah,
okay.
yeah, you are audible.
Okay. A large number of useful physical and chemical properties of these perovskite oxide resulted in availability of 90% metallic element for substitution at A and B site. Like in this structure, A and B sites are like that they can be substituted by various metal cations, as well as their anionic site can also be change. Easily production of hole or vacancy in their lattice. There is easily incorporation of hole as well as vacancy in the structure. These perovskite oxides are well known to perform interesting properties such as ferroelectric, piezoelectric, ferroelectric, optical, that result for their technological importance and attraction by the researcher. Therefore, availability of such interesting behavior in perovskite structure force the researcher to test their catalytic performance in various preparation and catalytic reactions. So the beauty of this is that they have the high potential in catalytic reaction. So basically researchers are focusing on these lattice to explore much and much in catalytic reactions. These are some sort of reactions that are followed by these perovskite oxides, like oxygen reduction reaction, oxygen evaluation reaction, decomposition reaction, photocatalysis, and selective catalytic reductions. Recently, I have published one review on this. And oxidation reaction by perovskite oxides. If we talk about only oxidation reaction, then these are the example where perovskite oxide behave as catalyst in catalytic oxidation of nitrous oxide, in complex oxidation of carbon oxides and methane, catalytic oxidative reforming of hydrocarbon, soot oxidation reaction, and many more are also there. In case of reduction reaction by the perovskite oxides, the catalytic combustion of volatile organic compound, catalytic NO reduction, reduction of NO by hydrogen, reduction of NO using ammonia as a reducing agent. So by varying reducing agent, there can be various reaction that can be followed by these perovskite oxides.
Sorry for the interruption.
Ma'am,
Slides are not being presented.
Ma'am, please conclude. You have only 1 minute.
Yes. So the conclusion is that overall these perovskite oxides have the beauty with their structural and properties, so that they can, based on their structural properties, they can be subjected to various catalytic reactions, as I have presented some examples. So up to here. So I would like to say thank you.
Okay, thank you very much, ma'am. And sorry for very tight schedule. Thank you very much.
Thank you.
Thank you so much, ma'am, for giving your time. Now we move on to the presentation of Maheshwar Thakur.
Ma'am, he is not present. He is present. Okay, Maneshwar, please present.
Yes, yes, sir, I'm present.
I will share.
Sir,
Can I share your slide?
yes, sir. Sir, is my screen visible? to you
Okay.
now?
Yes, your slide is visible.
Is it visible?
Yeah, it is visible. Please move forward.
Okay.
You have only 5 minutes, na?
Yes. Sir.
Maximum.
Okay. Good afternoon to all. I'm on combustion synthesis of octagonal zirconia. The overview of my presentation will include material synthesis and discussion. Zirconium dioxide. Dioxide is a wide band it has got band greater than 5 electron volts. It means it has got several states which are allowed in the forbidden gap. These states are allowed in the forbidden gap are due to the oxygen vacancy or interstitial defects that are inherent in zirconia. Got a energy the potential host hoping the rare earth ion which increase performance and it can be used in various LEDs lightning systems. Talking about zirconia, that is remain polymorphs with monoclinic with stay at 40 Kelvin. Tetragonal form with stable intensity from 2643 Kelvin. Cubic form with above 22 to the melting point. In the early 23 nanometer range of the range, it was that any thermal decomposition of uranium containing will produce only tetragonal phase. So we have used solid-state volume to the medicinal tetragonal form. The high temperature we have in the room temperature. The wall blocks the action between oxygen and fuel. Self-state thermal process and is used oxide as well as non-oxide. It has a step test which includes precursor, which we have nitrates or end of fuel, glycine, etc. Nitrate in furnace which is preheated at certain temperatures. And two events that take place in combustion are generation of heat combustion. The heat rate is very around 70 degrees heat is generated. Also involves large gas composition. Then this heat of combustion makes the product which very disposed, and it helps to sustainability of the product. Gas evolution we calculate the stoichiometric equation from the ratio of the oxygen using nitrate and the fuel. And the stoichiometric equation is given below. And results in this I have synthesized zirconium oxide at different to oxidant concentration. 875 again 60 and 160. However, the ignition temperatures which Masoth was picked was different. And 40. The XR graphs are shown on the right. It is evident that the samples synthesized ignition temperature is 0, 0, and 0. If we carefully and see that the products in nature, there is a certain which could be because actually and at 140 we can see the samples that they are in the phase in it so say that this is better stated. Looking at the find that they got what indicate that they have very small crystallite size. The crystallite size around 6 nanometers. Very made in this stuff is we have increased the to 1%.
Manishwar, you have 1 minute, please conclude.
Technical phase has been obtained. Next are the cumulative flows. Suppose samples. We see that when the pre-annealing is not done, because to empty the existing information in, we see the limitation of the peak maxima is there with the radiation, and at kilograms can see these data space transform which occur heating during the Z and Z samples. Equilibrium and peak imitate also shallow cracking 10 kg the day from 120 days the shallow cracking state form vacancy cycle take place in the radiation exposure. Next evaluation of the glow curves, we have calculated the type glow peak, the two from the shallow and glow peaks. For the second, retrapping is taking place with combination. As we move retrap, we add only the order of time is 1, meaning that motion is being placed that retrapping. And then thematic diagram of thermoluminescence in which we have trapped and tapped all of these steps upon thermally saturated go to conduction, they go to the recon center they produce emission. And at the conclusion, in which volume combustion is potentially taking the properties systematically by selecting emission temperatures, molar ratios, and to oxygen ratio. High fuel consumption volume the exothermicity, which increase that results in slight rise and transformation might draw samples that rays of gamma rays during the thermal simulation as indicated by the delta peaks, which I had shown the resistance B traps at we see the presence of shallow traps. Any queries?
Okay, Manishwar, thank you. Thank you very much for your nice presentation. Thank you, Manishwar.
Thank you.
Next.
Moving Moving towards the next technical session, I would like to invite Dr. Prasanna Kumar Sharma sir as the session chair. Sir is having a number of experienced years both in academics and in research. He has completed his PhD and he has a number of national and international journal publications. We are very delighted to invite you, sir. And we are very privileged to have you as such an eminent researcher with us.
Sorry to interrupt you, Pooja ma'am. Sir is joining within 1 minute.
Okay, fine, ma'am. We'll wait for him.
Panikar sir? Panikar sir is here or not?
No, sir, he is not present in the link right now.
Okay, okay, ma'am.
Vikas sir, in just 2 minutes, Prasanna sir will be there.
next technical session is from the Department of Chemistry, and we are having very good research scholars working in the field of chemistry with us. So for leading with that session, we'll take few minutes for our session chair to join us.
Ma'am, you will please start the invited talk by Latif sir. You will start. Actually, he is waiting since last 2 hours.
Okay, so beginning with the invited talk, we heartily welcome Dr. Latif from Belgium, and we invite you, sir, for your talk on effects of low dose rate B irradiation on the thermoluminescent properties of synthetic fused quartz. We heartily welcome you, sir, and over to you for the presentation.
Thank you very much. It's my pleasure to be with you. I want to upload my presentation in the first place. I think I'm having some little challenges. I'm not very sure what the problem is. Can you hear me?
Yes, sir, please.
All right. So let me open my presentation. Can you see?
Now
it?
your screen is visible, sir. Yeah.
Can you see?
Yeah. Please.
Okay. So the presentation is on the effect of low dose beta irradiation on the thermoluminescence properties of synthetic fused quartz. If there's a problem, please let me know. Hello?
Yes, sir, you are audible.
And you can also see my slides.
Yeah, it is visible.
Thank you very much.
Okay,
so the outline of my talk is an introduction about thermoluminescence dosimetry and also fused quartz, which I am presenting some results on, the experimental setup we used, and the results we have from these measurements. Thermoluminescence dosimetry has become a well-known technique for measuring radiation, absorbed radiation. It actually consists in first exciting the electronic structure of a material, and then causing excitation, as you have said, and then subject same material to heating to energize the electron, give them some thermal energy, and which will lead to emission of light as a luminescence phenomenon. And this is recorded by the setup, and the amount of radiation used for exciting the electrons in the first place should be proportional to the amount of light emitted. So this process is used to measure radiation for many applications, for personnel dosimetry, for medical application, for environmental monitoring, and so on. For the purpose of environmental safety, very highly sensitive dosimeters are required because we want to detect as low as possible. And also for that, you need some materials that can withstand a lot of environmental factors like heat, like weathering, like a sudden change in the temperature and environment, like maybe water, for example, if there's rain, and so many other things. So those are the factors that actually will detect the materials that should be used for such applications. Quartz is a hard material, crystalline in its natural form, composed of silica. It is generally represented as a silicon oxide, silicon SiO4. In its natural form is a tetrahedral. It is colorless to black, so it changes color from one place to the other, and that has to do with the impurities you have in. It is vitreous in nature. It has a very high melting point of about 1,670 degrees C, a specific gravity of about 2.65, and a hardness number of 7. In natural form, quartz actually represents the most abundant mineral on Earth in the hard crust. Quartz is the most abundant mineral we find, and it occurs in many temperatures, different temperatures. It can occur in igneous form as a form of rock that is solidified from magma. If there's an earthquake or something, quartz can form. Also, it can be metamorphic as a rock that underwent transformation by heating or pressure. It can also be sedimentary, formed by sediment deposited by water or air. So for the fused quartz, you need to have your number one, natural quartz. Number two, must be highly purified. And number three, we have to apply very high temperature for fusing it. And in the process, because we are applying temperatures quite high, most of the time higher than the melting point temperature, so we are going to break the bonds, we are going to modify the crystal structure. And of course, when that happens, it's also going to affect the thermoluminescence properties. So in the laboratory, this is what the setup looks like. We have a furnace on the right-hand side. The heating or the annealing was done at 400 degrees C for 1 hour, and then allowed to cool slowly to room temperature. Then on the extreme left, we have a TLD reader, the model 3500 Arshall TLD reader, which can be used to read all sorts of samples in solid form, from disk to rods to even powders and so on. And then in the middle, we have a computer with a program to read the output of the machine. Of course, in the extreme left-hand corner, we have a gas bottle, nitrogen gas, which is necessary for the heating of the dosimeter inside the machine. This is going to create an inert environment to avoid combustion during heating. So if we look at some of the reports, of course, as I said, if you look at the properties of quartz that has been reported, we can see different glow structure. Glow structure is the response we get from the thermoluminescence reading. And you can see from the very first one that was reported in radiation effect and defect in solids, you can see that the prominent peak occurs at around 300 degrees C, and that the peak that corresponds to what we see in this sample occurs around 150, between 100 and 200 degrees C. If you look at the one on the right-hand side, you can see that the peak that corresponds to what interests us is also more of a shoulder peak here, and it occurs also, of course, at around 150 degrees C. It occurs here as a second peak. And then if you look at the one at the bottom, reported in radiation measurement in 2006 by Ogundare et al., you can see that that peak is actually the second peak that we observe here. So these are also due to this origin of the quartz sample and also the shape and the specific properties of the quartz sample. Yeah, so the TL readout of our sample, they were all read out at 5 degrees C per second, is a single glow peak, a broad glow peak that occurs at around 155 degrees C, and which is consistent with increasing absorbed dose. So here, because we use a very low dose rate for the radiation, and this is the essence of this particular study, we had a dose rate of 40 microgray per minute, which gives us a dose of 2.4 milligray per hour. So we had to expose the sample for several hours, from about 30 minutes to about 2,000, very close to 2,500 minutes exposure. We have the response as this. It's quite a linear response over that long period of exposure. The slight deviation we see here can be attributed to the slight changes in the mass of the chips. When you look at the fading study, for the fading, we had to irradiate the sample to a given test dose and then store it at room temperature and be reading after days. So the first reading was taken after 1 day, and then 2 days, 4 days, 5 days, 7 days, and then 10 days. And what we notice is that after 10 days of waiting, of allowing the sample to decay by itself without heating, only due to room temperature, we noticed a loss of signal accounting to about 28% in the peak height. So if you look at the peak, the height of the peak for after the first day of reading to the one after 10 days, you can see there's quite a noticeable change in height, and that amounts to 28%. But this might not be sufficient to really evaluate efficiently what the decay is actually, because if you look at the high temperature tail, it's quite noisy. And this is an indication of loss of signal as well. So it will be interesting in this situation to look at the integrated TL response for each of these, which is going to correspond to the area under the curve for each of these glow peaks. And when we do that, within error limits, we see there's actually effectively a loss of about 20% of the signal in 10 days. So this is an indication that the broad peak observed in synthetic fused quartz is suitable for low dose environmental monitoring for a reasonably short period of time. It's quite very efficient, up to 10 days, for example, probably beyond also. Yeah. So now we want to look at the properties, the specific properties of the glow curve, which is of interest to us for many reasons. Number one, it is important for the glow curve reproducibility. Number two, it is also important for glow curve stability. So if we look at the geometric factor of the glow curve, all we do here is to take the center of the glow peak, and then we take the distance that corresponds to from full width at half maximum, half the height of the glow peak, and then the value corresponding here. So the temperature range from that to the middle, and then to the second half, okay? And then we do this ratio of the first half to the second half. That corresponds to what we refer to as a geometric factor. From a first view, you can see that the first half is lower than the second half. And this is not what we expect from the models that we know. For example, if we consider a first order peak, you will see that the drop after the peak temperature is quite a fast one, such that the first half is significantly greater than the second half. If we have a second order peak, we are going to have quite a symmetrical glow peak, such that the first half is almost equal to the second half. But here it is quite the opposite. And this is an indication that our glow peak is not a single glow peak, it's a convoluted one. So we need to deconvolute it. So, sorry for my voice. So if we look at the full width at half maximum, which is the width of the resonance, compared to the symmetrical geometrical factor, which was calculated as the ratio of the first half over the second, we can see that we have a tendency of this as a function of irradiation time, or as a function of dose, is the same thing, because the irradiation time is a function of the dose, since we have a constant dose rate. So over the exposure time, we can see that initially it was quite large for the full width of half maximum. This is expected because at that time the glow peak is not fully formed. And then as it increases, there is a slight decrease and then an increase and then followed by another decrease. But the beautiful thing we notice is that there is a symmetrical effect from the geometrical factor such that we have a mirror. So the geometrical factor is a mirror of the full width of half maximum. This is important to report. Also, if we want to know the exact number of glow peaks that we have, because we can't just guess the number of peaks that we have. So we have to apply what we refer to as a fractional glow curve method. So this technique will require that we irradiate the sample to a given dose, and then we begin to read on segments. We need to read the sample on segments. We have to first read and then we stop. And the essence of that first reading is to clean the TL signal in that range. and then we apply a normal region afterwards. And when that is done, we get a glow peak. From that glow peak, we determine the activation energy using the initial rise method. But the problem with that also is that the initial rise method for calculating glow peaks, at times, most of the time, is not totally accurate because of what we refer to as a quenching, thermal quenching factor. So because of thermal quenching factor, we might have some values that are actually slightly lower than the exact values. So most of the time, it is good to have one or two methods for evaluating the kinetic parameters so we can have a comparison and have reliable values. So using that, here, there is some sort of limitation in this measurement in the sense that I chose a range of about 15 degrees C, which I discovered was a bit high. If I had values like a step change of 5 degrees C, it would have been more interesting. So I could have a better view of most of the steps that we see. But this, because it is done in combination with another technique, I could easily identify my peaks. So here we have the first peak and then the second peak. And then, so all these signals, these correspond to each of the peaks. And clearly we could identify 7 glow peaks. We do the same thing as we have said, calculate the activation energy. We plot the activation energy also in the same approach. And we are going to have a flat region. Each flat region is going to correspond to each peak. So the combination of these two is going to give us the exact activation energy values and number of peaks. So these are selected T-stop plots. This is after erasing the signal in that region. This, I think, was from 65 degrees C. We have a peak temperature of 50, so 50, 65, then 70, then 85, then 100, and so on. So these are some of the selected glow peaks we have after the T-stop technique. Now we deconvolute our glow peaks, and we have it in this form. Actually, these are the 7 glow peaks at each of these positions. And then noticeably, there is a low, a shallow peak towards the end of at the very high temperature here, the region. And this is going to be crucial for our study. It's going to help us explain some of the things that we observe here. So when we combine the two techniques, the maximum temperature values 158 plus or minus 10. This is the error of the machine, plus or minus 10 degrees C. For the glow curve deconvolution technique, we have a value of 140. This is quite comparable. The activation energy we get here is also 1.4 compared to 1.2 in this place from the initial rise method. As I said, the value measured with the initial rise method are generally a bit lower than the actual value. So this is still within limits of error. These are comparable values. So, and then also we were able to extract the frequency factors. Since they are first order peaks, so we can easily, since if we know the activation energy and the maximum temperature, we can calculate the frequency factor. And the figure of merit for this fit was about 3%, which is quite okay. So this is the model for the trap recombination. This leads us to investigate what actually happens in the material, because we are applying a low dose rate, and then we are concerned about some of the signal being lost while the radiation is still on. Is the signal lost or not? This is a good question to ask, because we are irradiating at a low dose rate of 40 microgray per minute, 40 microgray per minute. Every minute we have 40 microgray, 40 microgray, 40 microgray being given to the material. And then we do not know if at that room temperature, within the 1 minute, if some signal is also being lost. This is important to us. So the easiest model to use in this case, since we're having a first order peak, it is one recombination center, 2 traps model. In the first one here, we have the trap concentration, N1, and the occupancy, small n1, the activation energy, E1, and then the frequency factor S1 for the first trap. And then we make a second trap slightly deeper. Why? Because our model, what corresponds to our model here is a first order peak. It has to be deeper such that the probability of the material trapped or the carriers trapped in this one are not released compared to this one. So the signal, the TL signal we see will be originally or mainly from the first trap. So this will generate 5 differential equations that we have here, which we have to solve simultaneously to be able to identify, to calculate the time. The factors we get here in the end is actually to see the difference in time from irradiation and excitation and decay, to see if it is not significant enough to have a causes loss of signal while the radiation was still taking place. Now, if we look at our fading peak after 10 days of exposure, as I said earlier, we can see that there are some noises around here at high temperature till we have significant loss of signal, and that is attributed to the shallow glow peak, which has an activation energy of 0.5 electron volt at that high temperature, and also a very small value of frequency factor. This, of course, is clear that the signal loss is due to this peak. However, when we look at the peak height, when we use the whole peak, glow peak, the broad glow peak as a dosimetric peak, there is no significant change as we have seen in the dose response curve. So in conclusion, we can say that synthetic fused quartz has a very good dosimetric property with a single glow curve structure, a linear response to beta radiation, and a relatively low fading at ambient temperature. And this, the implication of this is that it's okay for environmental light radiation measurements. The glow peak observed actually is a convoluted peak of 7 first order peaks whose parameters have been successfully determined accurately within error limits of error, experimental error. And also, owing to the crystal structure of this material, the properties are highly altered by heating, such that the reuse of the material might not be appropriate. And we discovered that also in the laboratory. We discovered that after reading a sample and then re-annealing and then coming back to study it, re-irradiate again, the signal we get is not the same. This is understandable because the material is amorphous and not crystalline. So the crystal structure is not recovered. Yeah. However, it is good for low dose environmental monitoring. Thank you very much.
Thank you very much, sir, for such a brief and wonderful presentation. Is there any questions? Any questions?
Yes, sir.
Yeah, please go ahead. Keep your questions brief, please.
Want to see peak parameters.
Yeah.
Am I?
There's some audio glitch. We'll move on. Next speaker.
Thank you very much, Dr. Latif, sir.
Thank you very much, sir. Thank you very much, sir.
No problems.
Our next speaker is Dr. Jelena Mitrik, Assistant Research Professor.
Hello, sir.
Yes. Hello.
Sir, she is not present here.
She is not present yet.
Please move forward for the oral presentation of chemistry and
Hello, sir.
communication skills.
Hello, sir.
Yes, we can move to the oral
Because sir,
presentation.
we Panikar sir,
Yes, ma'am.
Prasanna sir is there. Prasanna sir is there.
Okay.
Session chair. And we will start the chemistry presentation, oral presentation.
Yes, yes, ma'am. You may please start with the oral
Yes, sir.
presentation.
Yeah, thank you, sir.
Yeah,
Thank you, sir.
yeah.
So, respected all, here we have our session chair, Dr. Prasanna Kumar Sharma, sir. Sir has proctor in Amity University, Raipur, and sir has a number of research papers in his credits. Sir has also experience, industrial and as well as teaching experience, a huge teaching experience also. So I invite Dr. Prasanna Sharma, sir, as session chair for this technical session 5, day 2. Sir, all over stage is all over street.
Dr. Shilpa, am I audible?
Yes,
Hello?
sir.
Yes,
Sir, you are audible.
Thank you, ma'am. First of all, I'm very, very, very sorry that I have joined the session late because of some of my personal issues. And I just joined when Dr. Latif was on very nice and informative presentation. So, first of all, congratulations to all the teams for inviting me and this type of such knowledgeable persons in international conference. And I really miss Dr. Jelena. I think she was not joined because of some reason. So if you permit, then we can start for the this your presentation.
Yes, sir. Please.
Oral presentations.
Okay. So as per your given list here, the first presentation is by Dr. Chandra Prabha Sahu, if I'm not wrong.
Yes, sir. Dr. Chandraprabha Sahu. Yes, sir. Arka Jain University. She is from Arka Jain University.
Arka Jain University, Ranchi, on topic of that is fluoride content present in groundwater in a diverse area of Jharkhand. That is a review paper. Dr. Sahu, are you ready?
Good afternoon, sir. Yes, I am present, sir.
Yes, please start your presentation.
Is my slide is visible right now?
Yes, ma'am, please.
Okay. Okay. So I'm going to give my presentation on fluoride content present in groundwater in diverse area of Jharkhand review. So as we all know that water is the most precious and abundant component in our world, and hence few treatment would be required to make a groundwater potable in a few area of India. Therefore, it is also required to have additional sources to fulfill the requirement of fresh water in our country. Fluoride in drinking water is essential for bone development, dental caries, but on the other hand, it is also causes dental and skeletal fluorosis. Globally, about 25 nations with 200 million people are suffering from the dreadful fate of dental and skeletal fluorosis. Numerous research have reported the occurrence of fluoride concentration in drinking water from all around the globe. Fluoride is the 13th most abundant element in the earth crust, basically in fluoride-bearing minerals such as fluoride, biotite, and fluoroapatite. Several factors such as underlying geological, aquifer, material, water interaction, pH, temperature, solubility, and availability of fluoride extra influence the enrichment of fluoride in groundwater. The presence of fluoride in drinking water has some health benefit for consumer, such as reducing dental cavities, but an excessive intake of the anion and its presence at high concentration can lead dental and skeletal fluorosis. Fluoride contamination in groundwater is one of the foremost natural mischief for the different district of Jharkhand. The present study was carried out to the concentration of fluoride in the groundwater of different area of Jharkhand. It is evident from the literature survey that the Jharkhand state are more prone to fluoride exposure due to the consumption of fluoride contaminated groundwater, and the major source of fluoride in groundwater is a geogenic and includes many rock forming minerals. And the present review aims to describe the contamination fluoride in Jharkhand state and its possible health effects and remediation techniques. In Devghar, mostly groundwater resources is used for drinking purpose, and the groundwater has certain dissolved ion, among which the presence of fluoride has gotten attention as it required by the human body of mineralization of bones under permissible limit, not beyond a limit. As per the WHO standard prescribed, maximum level of fluoride in drinking water is 1.5 milligram per liter, but the required desirable limit of fluoride concentration in drinking water as 0.6 to 1.0 milligram per liter, and it is considered as a fluoride contamination. When fluoride concentration increases beyond 1.5 milligram to liter to 3 milligram per liter, it causes dental fluorosis, discoloration, and feeding of teeth. Devghar is also severely affected by minerals contamination like arsenic.
Ma'am, your slide is not moving.
It's not moving.
Yeah.
Sir, I'm moving my slide.
Please.
So now it is moving.
No, ma'am. Please present your screen. Firstly, you will share your screen. Yeah, now it is visible. Okay, ma'am, it is visible now.
Groundwater, so Devghar is severely also affected by many TDS in groundwater, and a few yearly study has done on the fluoride contamination in Devghar city of Jharkhand. Groundwater is the main source of drinking water in different area of Devghar city, and so this study was focused on fluoride concentration of different area of the city, find out the fluoride concentration in under its permissible limit and beyond limit. The lowest concentration of fluoride was observed 0.343 milligram per liter in civil line of West Zone, and the highest concentration was found 1.67 milligram per liter in Jarodi, and on North Jor it is found as in a concentration. The Jharkhand is mostly occupied by hard rocks and 90% of geographical area where groundwater occurs in irregularly distributed secondary porosite, and the factors groundwater occurrence and movement and two cardinal parameter water bearing zones, and the state of groundwater development is less than 10% in state, and stress on groundwater reside in visible some urban and agglomerators like Ranchi. The state preserve the geological history and the concentration of different area in Jharkhand district of fluoride is like Bokaro. We have a 2.5 milligram per liter, Giridih 1.60 milligram per liter, and in Giridih Tirsi district at 1.80, Goda 1.81, then Palamu 2.18 to 2.46, and Ranchi 2.60 to 2.50. So in this study, we have found that we have discussed about the various researchers which have done this fluoride tested, and all suggested that fluoride pollution in the area due to rock water interaction and more exploitation of groundwater resources Defluoridation is also suggested by eating herbs which have medicinal values. So presently, fluoride contamination in water has dramatically increased due to urbanization and world population growth, and the presence of fluoride in higher amount than the permissible limit in groundwater has created serious health problems. Nearly 12 million of the 85 million tons of fluoride deposit on the earth crust are found in India, which might be the reason of a high fluoride concentration present in the occurrence of the groundwater. In our present study, a review of groundwater resources of Jharkhand has been carried out to define the groundwater quality system based on the major ion chemistry, and this will help the current water resources planning of Jharkhand and provide an overall idea for contamination of groundwater in Jharkhand. Thus, it is observed that the quality of groundwater in the entire state is suitable for drinking, irrigation, industrial purpose, except in arsenic, fluoride, and other chemical infested area. The present review study will give an acute awareness among the people of the Jharkhand about the quality of groundwater, and proper awareness program and water management plan for groundwater quality is needed in a Jharkhand, which can help the individual and the community use pure drinking water and minimize water pollution. Thank you.
So, Dr. Chandraprabha, it was a very nice presentation indeed. And the topic is now open for the question and answer session. If anyone have any question, any query, then please. Anyone, any question? Okay, okay. I think there is no questions. I have just one doubt. You can say it's a query. Dr. Chandraprabha, can you, it is audible, I am audible to you?
Yes, sir.
It was a very nice analysis and review by you, that is the fluoride content present in groundwater. Is there any specific treatment process or any suggested process has been installed by the state government in Jharkhand? Have you been observed any such type of parameter or any such type of arrangement done for the removal or treatment of groundwater where the high content of fluorine is present, because it is directly affecting the disease to the newborn babies also?
Sir, actually, right now we found that in a many area of Jharkhand there is a giving a positive responses to the fluorosis, because as usual in a day or to be life we are clearly observed that the dental fluorosis and other problems are facing by the Jharkhand people. In the state of Ranchi, in the state of Jamshedpur, in the state of Saraikela districts, we generally observe that a high fluoride content is present in our water and it is not removing at all.
Okay, okay, okay. So it was not up to that remarkable amount is present there. Okay. Thank you, Chandraprabha, Dr. Chandraprabha Sahu. Yes, thank you, thank you. Our next presentation is Girija from Maths University. Present, Girija?
Yes, sir, I'm present.
Yes, yes. And your topic is a study on the water quality of Raipur. Girija, please start your presentation. PG student, that is very interesting.
Good afternoon, everyone. My name is Girija Patel, and I am pursuing MSc from Maths University. The topic of my presentation is study on the water quality of Raipur. Introduction. Water plays important role in maintaining the human health and welfare. Water is subsistence of life cycle. It must be retained and protected from all type of pollutant. According to the definition of WHO, foreign material either from natural sources or other sources are contaminated with water supplies and may be harmful to life. Because of their toxicity, reduction of normal oxygen level of water, aesthetically unsuitable effect and spread of epidemic disease. Pollutants of water. Pollutants of water are domestic pollutant, industrial, agriculture, radioactive, and thermal pollutant. Domestic pollutant, the sewage contains garbage, soap, detergent, waste food, and human excreta, and is the single largest source of water pollution. Industrial pollution, many industries such as textiles, sugar, paper and pulp mills, tanneries, and pesticides are responsible for discharging their untreated effluent. Agricultural waste, manure, fertilizer, pesticides, waste from farms, poultry farms, these are the sources of agricultural waste. Radioactive waste, uranium and thorium mines, nuclear power plant, research laboratories, and hospitals. They use isotopes. Thermal source. Various industries, nuclear power plant and thermal plant require water for cooling, and the resultant hot water is often discharged into river or lake. This results in thermal pollution and leads to imbalance in the ecology of water bodies. These are the general guidelines for sampling. Uh, Container should be cleaned 3 times before it filled. Label the sample container properly. Code and sampling date should be clearly marked. Complete the sample identification form for each sample. The sample identification form should be filled for each sampling, and the identification form should be kept in a master file at the laboratory. Purpose of study. The purpose of my study is to assess the hydrogeochemistry of groundwater as well as surface water quality of the Raipur. In this study, 4 water samples were collected from different sources. BIS, standard Indian standard limits, these are as follow. A parameter for pH, acceptable limit is 6.5, permissible limit is 8.5 for total hardness, 200 and 600 for magnesium, 300 to 30 to 100 for calcium, 75 to 200, and for chloride to 50 to 1000 ppm. Water quality parameters, these are the parameters: pH, total hardness, magnesium, calcium, chloride ion, total organic solid, total inorganic solid. pH. The term pH refers to the measurement of hydrogen ion activity in the solution. Since the direct measurement of pH is very difficult, specific electrodes are needed for quick and accurate pH determination. pH is measured on a scale of 0 to 14. The lower value of hydrogen ion indicate more acidic, and higher value indicate less acidic. A pH of 7 is considered as neutral. This is the result of my case study. For sample 1, pH reading is 7.9, which is under permissible limit. For sample number 2, 7.5, which is also under permissible limit. And sample 3, 8, and 4 is also 8. Both are under permissible limit. Total hardness. The simple definition of total hardness is the amount of dissolved calcium and magnesium in the water. Types of total hardness. This is two types: permanent and temporary hardness. The method used in this is complexometric titration. EDTA titration method measures the calcium and magnesium ion. This is procedure. And for calculation, we use simple dilution equation, which is N1B1 is equals to N2B2. This is the result, where total hardness for sample 1 is 120, which is moderately hard. Sample 2, 235 hard. Sample 3, 90, which is moderately hard. And sample 4, 100, moderately hard. Calcium hardness. The average abundance of calcium in the earth crust is 4.9%, in soil, and in groundwater it is 1 to 500 milligram per liter. BIS limit for calcium hardness is 75 to 200 ppm. Titration method is used for the determination. Now, this is the result of calcium hardness for sample 150, which is below the acceptable limit, and sample 268. Sample
Girija,
Yes.
I think there is some defined time for presentation. Can you please go for the resultant discussion?
Yes, sir. Sir,
before this conclusion and before this?
sir, all are result only. I'm showing
Okay,
only
okay,
result.
okay. Can you summarize the result and what is your main
Girija
focus?
Patel.
And can you summarize your result only?
Oh, okay, sir. Huh. S- all the tests we have done is compared to BIS limit and
Okay. Girija, just conclude your first. Hai na? Yes.
so in this present investigation, it was found that the maximum parameters were not found at the level of pollution. So we can conclude that sample satisfied the requirement for the use of various purpose.
Okay. Right. Girija, first of all, I want to appreciate that you are a PG student. You have been done such type of presentation. This is just really appreciation. Hai na? And the topic is open for the discussion in the forum. If anyone have any question, any query, or any suggestion also, please raise your hand or open your mic. Okay, no problem. Girija, I have one question. Hai na?
Yes, sir.
You have been mentioned that you collected the sample from 4 regions. What are the regions where you collected these samples? The area of sampling is in the Raipur, which area?
Sir, 4 samples, different locations from different locations were collected. First sample is from Budha Talab, second is from Boria Kala, which is industrial area, and third is from Kendri village, and fourth is Pandri.
Okay, and how many samples are from surface water and from groundwater, or you can say bore water sample?
Budha Talab sample is from surface water, Boria Kala from groundwater, and Kendri is from surface water. Pandri is also groundwater.
Okay, so 2 is surface water and 2 is from groundwater. Okay.
Yes, sir. Yes,
Okay,
sir.
nice work done by you, Girija. So thank you for your presentation.
Thank you,
Our
sir.
next presentation is Nina Bakchi. Are you there, Nina Bakchi?
Nina Bakchi is not there.
Okay. So Priyanshu Saw.
Again, sir, Priyanshu Saw is not there.
Okay, Priyanshu Saw is also absent. Neha Verma.
Sir, unfortunately, she is not there.
Okay, no problem. Next one is Alka Banchor.
Sir, she is willing to join, but I think there is network glitch. She is a scholar of BIT and she is willing to join, but
Yes. Two of the students are from BIT. Yes. So Nikita Manikpuri is there.
Yes, sir. I'm present.
Yes. Nikita Manikpuri is here. So Dr. Shilpa, if you permit me, so start the presentation of Nikita.
Sir, sure, sir.
Okay, Nikita, are you ready?
Yes, sir.
And Nikita's topic is a study on predict the requirement of purification of water of Rajim area.
Yes, sir.
She's a PG student from MERS University, Raipur. Okay, Nikita, please start your presentation.
Yes, sir. Good morning or good afternoon, all of you. My topic is a study of predict the requirement purification of Rajim, submitted by Nikita Manipuri and supervision.
Nikita made it your presentation mode. It was just a slide mode. Convert your presentation in a properly presentation mode. A single slide presentation.
Yes, sir.
So just press the play button.
Sir, she is presenting in a mobile phone,
Okay, okay.
so there is issue. So kindly permit.
Okay, okay. Nikita, please continue. Again, share your screen.
इसी में से कर दूं?
Yes, yes. Now it's better.
So this is content. First introduction, water parameters, pH, COD, BOD, and conclusion and acknowledgement. First introduction, water chemistry analysis are carried out to identify and qualify the chemical components and properties of water sample. The type of sensitivity of the analysis depends on the purpose of the analysis and the anti-conceptual use of water. Next, my study area, I'm collecting samples of Rajin, Nayapara, Abhanpur, Rajim is Mahanadi river and Navapara industrial wastewater, Abhanpur borewell water, and Basti Abhanpur is pond water, and Abhanpur is pond water also. Next, my parameters. Water quality parameters included chemical, physical, and biological properties can be adjusted or monitored based on the desired water parameters. Parameters that are frequently sampled or monitored for water quality included temperature, pH, COD.
Nikita, will you please proceed for your analysis part directly?
Yes. First, pH. It is the negative log of the hydrogen ion. It is measured on a scale 0 to 14. This is the picture of pH scale, and this is a picture of pH meter. This is a graph of my sample waters, and this is the observation table. My pH meter reading is under the permission of limit. Next, chemical oxygen demand. Basis permission, the chemical oxygen demand test measure the oxygen required to oxidize organic matter in water and wastewater sample via the action of strong oxidation agent under the acid condition. This is the COD measurement and COD measurement formula. This is a calculation formula. My COD result is of rice mill wastewater near Nayapara, Rajin has found 2525 milliliter. It is very highly for COD calculation. Next parameter is BOD. The bio-oxygen demand tested measure the oxygen consumed by microorganism is depending organic pollution of wastewater. The pH measurement. This is a formula of pH measurement. Now the result of BOD of rice mill water near Nayapara Rajin has been found at 505 milliliter. Next parameter is organic and inorganic solid. Introduction. The term total volatile solid refer to materials that are comparing volatiles from water at high temperature 550 degrees Celsius. The principle of organic and inorganic solids, the sample of evaporated in a wet dish on a
Nikita, please skip this slide. Please go ahead. Again, skip this one. Again, go for your discussion. Come to the next slide. Observation table for organic solid. Okay.
And this is a graph for organic solid, and this is the observation table for inorganic solid and graph of inorganic solid. Next parameter is the heavy metal of chromium. Under acidic condition, hexavalent chromium react with as diphenyl carbazide to form a reddish violet color complex which can be determined either usually or photochemically. This is a graph for chemical chromium standard. Conclusion. The water sample of all locations contain limited amount of pH, organic solid, inorganic solid, COD, BOD, but lower than other depot studies. Acknowledgement. I would like to thank Professor Sangeeta Sahaman who gave me a valuable suggestion and guidance for this topic. Thank you.
Okay, Nikita, just a very interesting analysis done by you, and because you are the PG student, if I'm not wrong. So
Yes.
really, again, appreciation to your work again, and appreciation to your guide also for doing such type of work. Now the topic is open for discussion and question, query, suggestion from any of the member present here. Okay, no query, no question. So, Nikita, I have just make observation that your sample 2 has a notable pH of 6, that is slightly below than the normal pH. And again, sample 2 have a maximum report of the organic solid and inorganic solid.
Yes, sir.
And
Professor,
this sample 2 is at the location of Avanpur, nearby the area of Avanpur, if I'm not wrong.
this is sample of industrial water for rice mills, sir.
From rice mills. Okay. And your COD is again at remarkable high in the Rajim rice mill affluent. Okay.
Yes, sir.
Okay. So is there any impact of these all effluent which has a remarkable organic solid and inorganic solid fluid in the Mahanadi River? So is there any remarkable change in the water quality of Mahanadi River in the future as per your analysis?
Sorry, sir, I can't understand.
What do you think that is there any remarkable change may observed in the river water of the Mahanadi, because it is heavily loaded with the affluent of rice mills in the area of Avanpur to Rajim?
Sir, because COD is very high, and so beauty is
Yes, please. Because all rice mills are there in Rajim area, or you can say in Avanpur area. I know well that they are not treating their water when discharged into stream. I know well. So what do you think that?
is very high for the reason of pollution.
Okay. Thank you, Nikita. Thank you. Dr. Shilpa, is there any presentation is expected? We are expecting.
Sir, one presentation from physics department.
Okay.
K. Deshmukh, sir.
K. Deshmukh, sir. Okay. K. Deshmukh, sir, are you ready?
Yes, sir.
Please start your presentation. Please.
मैं बोलते समय ना ऐसा माइक से मुख के सामने रख लेना था, ठीक है, आवाज ऐसे क्लियर थी।
It is visible, sir. Hello. Sir, it is visible.
Yes, it is visible. Please go ahead.
Okay, thank you, sir. Good afternoon, all who are here present in this session. I am Ram Krishna Deshmukh, PhD scholar at University, and I have done PhD under the guidance of Dr. N.K. Kumaraswamy sir and Dr. Vikas sir. So today we are going to present some research part of our research in this. So this is the topic of synthesis and characterization of the luminescence property of rare earth, samarium doped erbium silicate phosphate for the light application. So these are the content of our presentation. So this is the luminescence. Luminescence is a emission of light after excitation of some photon. So there is a two type of the luminescence: phosphorescence and fluorescence. So these are the rare earth materials. They are included to another scandium and so total 17 elements consist of the rare earth material, because it's a very complex extract process, so it is called the rare earth. And the project we have used some rare elements like gadolinium, lanthanum, erbium, yttrium, and other some rare earth materials. Some other property of rare earth material. So there is a type of different type of luminescence depend on the excitation condition. So go to next slide. Okay, excitation and type of luminescence application in phosphor. Okay, I have studied some closest literature survey of my topic. After that, I have decided to easy selection of the material to support our research area. Okay, so after the review of literature, I have decided to some special property of erbium is a and co-dopant is a samarium. So we rare earth phosphor like gadolinium, lanthanum, and erbium. So these are the three series I have chosen. So today we try to explain third one, the erbium with the dopant material of samarium.
You have only 2 minutes.
This
Please
is the,
conclude. You have only 2 minutes. Please conclude. Okay.
So okay, thank you, sir. These are I have choose the different dopant properties 0.1, 0.2 to 3%, and I have choose the method of sample preparation. That is the solid state reaction method, and right side flow chart have conclude the how we prepare that material. So these are the elements to support our preparation of sample, and this is the picture actual picture I have tried to design the ML mechanical mechanoluminescence setup for the manual luminescence extraction. So I have show this process of how to read the luminescence after the mechanical excitation of sample. Okay, put down the heavy cylinder to upside to the lower, and lower side we put the prepared sample. Then after the heat excitation of sample, we radiate the luminescence of light, and that inside the PMT read the how much luminescence is radiated from, and with the help of TC, we compare the result. So this is the picture of same result. We extract from the Kalinga University 0.1% of my first series gadolinium and yttrium doped phosphor, and okay. So I think thank you, sir. This is the reference to use the this. Okay, thank you, sir.
Okay, Mr. Deshmukh, and now the topic is open for discussion, questions, and suggestions. If anyone have. If anyone have any question, any query related with this topic, please. Okay, I think no one had any question. Is anyone who has been skipped or absent in this session has been joined?
Sir, one more candidate left here. Khushbu, she is from Metz University and she is very enthusiastic to present in her first introduction to business. So please permit her to present her work.
Okay, but please take care of the time.
Thank you, sir. Can I leave?
Yes, sir. Just 2 minutes.
Thank you.
Khushbu, please
Yes.
present
Yes. What is the name of the candidate?
Yes, sir. Sir, Khushbu Tirki.
Khushbu.
Yes, sir.
Yes, sir.
Khushbu, please start your presentation
Yes, sir.
and take care of the times. Huh?
Okay, sir. Good afternoon, everyone. Myself Khushbu Tirki. I am from Metz University. My topic is water quality analysis of different sources of Raipur district, Chhattisgarh. This introduction. Water is the most important need for life exists after air. As a result,
Please skip the introduction. Directly
Yes,
go
sir.
to the
Okay,
analysis part. Okay.
Yes, sir. Sir, these parameters, sir.
Please skip this one is also.
Okay, sir. Sir, pH
Now
chart,
this
sir.
is the result. Hai na? Okay.
जी. Total hardness. This graph, sir.
Wait a minute. And the analysis part of total hardness is the results are at MLD. How much this one is? Total
जी,
hardness.
sir.
Total hardness.
जी.
Yeah. No, this one is total.
Sir, magnesium. Sir, this chart, sir. And sir, total acidity.
Okay.
This graph, sir.
Wait a
Alkenic.
minute. Wait a minute. Huh? Wait a minute for acidity. Go back.
Yes, sir.
Now. The acidity parameter for the highest peak is 390. In which area? This is in Tilladi.
Sir,
No, sorry,
Teribanda
Telibanda.
Pond Water,
Telibanda
Raipur, sir.
Pond.
जी जी
And in Amlidi it is 125, and total hardness in
जी sir.
Amlidi was found more than 300. Okay, right. Please go ahead.
So this alkalinity, sir, and this chart, sir, total alkalinity.
Okay. Alkalinity is highest in Amlidi. Amlidi in which area? It is a pond sample or hand pump sample?
Okay, sir, hand pump water, sir.
Please, next.
So this TDS total dissolved solid. Sorry, chart. TDS
Right.
chart.
Stay here. The TDS is again in highest for your one of the sample.
Kendri hand pump water, sir.
Okay, Kendri hand pump water. So total sample is taken from 5 area or 4 area?
Yes, sir.
Total sample has been taken from 4 area or 5 area?
Sir, 4 area.
The Amlidi pond water, Amlidi drinking water, Amlidi bore water was also there, hand bore water also there?
Sir, pond water and drinking water, sir.
Okay, and Telibanda pond
Kendri, okay, pond water and drinking water, sir.
water. Okay, please proceed on.
And then sulfate, sir, this sulfate, this charts are sulfate chart.
Now, will you please explain this chart?
So Amlidi pond water, sir, 262 ppm, and Amlidi drinking water, sir, 0 ppm, and then Kendri hand pump water 557 ppm, and Telibanda pond water, sir, 0 ppm.
No sulfate
This
was
sulfate,
present in Telibanda.
जी sir.
Okay.
And this conclusion, sir, the water sample of all location contain limited amount of pH, total hardness, calcium, magnesium, TDS, sulfate, but lower than other reported studies. In this present investigation, it was found that the maximum parameters were not found at the level of pollution. So we can conclude that the sample satisfy the requirement for the use of various purpose. Thank you, sir.
Okay. Thank you, Khushbu. The topic is open for the question answer session. If any member, any present here wants to say something regarding with the query, suggestion, any other thing, please proceed. Anyone? Okay. Khushbu, I have just one query. You have been showing me that the sulfate present in the Telibanda pond is almost zero. You can say it was not remarkable to be pointed out. And in one of the area is very high concentration, sulfate concentration. What is the reason of, as per your analysis and as per your knowledge, what is the reason of the highest concentration in that particular area of the sulfates? I think it is in Kendri. Khushbu?
Yes, sir.
All right. Can you guess the reason why the sulfate is so much high concentration in that particular area and other area it is not present? What is the reason?
Sir, 7 ppm कुछ something, sir.
No, I want to know the sulfate concentration.
Sulfate concentration. I have no idea, sir.
Okay, no problem.
जी.
No problem.
जी.
Okay, please. Thank you, Khushbu.
जी, sir. Thank you, sir.
Thank you so much, sir. Thank you for your valuable time and have patience for chairing the session. And on behalf of the Institute of Technology, I really thankful to you and your precious time. And thank you so much, sir.
Thank you once again, but I'm very sorry to say that I was late in the session, but I really thanks to the organizing committee, the members of the Bhilai Institute of Technology for organizing such type of international conference and giving me.
Thank you so much, sir, for giving your valuable and precious time to us.
So now it's time to draw curtains of this two-day international conference on recent trends in renewable energy and sustainable development. So for concluding remarks, I would like to call Dr. Shilpa Sharma ma'am, co-convener of this conference, to proceed with the concluding remarks of the international conference. Ma'am, please. Ma'am, you are not audible. Kindly turn on your mic, please.
Yeah, sorry. Okay, thank you, Pooja ma'am. Thank you very much. I'm very honored and delighted to deliver concluding remark on the last day of third international conference on recent trends in renewable energy and sustainable development, organized by Villa Institute of Technology, Raipur, on 29th and 30th of April 2022. I'm extremely pleased that this conference was well attended by various stakeholders ranging from scientists, academicians, research scholars, PG and UG students with insightful content. On this two-day conference, we have 5 technical sessions in hybrid mode, that is online and offline sessions. For better approach with all our international and national participants, the inaugural ceremony was live streaming on YouTube also. Inauguration ceremony is started with welcome speech by our respected Dr. T. Ramarao sir. Our director sir has joined us from United States of America. Then official inauguration speech was delivered by our respected principal sir, Dr. Anup Mishra. Welcome speech as well as briefing of 2 days conference is delivered
I think I'm visible now. I'm audible, sir? I'm audible, sir?
Yes.
Yes.
Okay. So, yeah. So in 2 days conference, we have 2 pre-conference talk in our credit in day 1 on itself. That is delivered by Dr. Jayant Nirmalkar sir from Jeonbuk National University, Korea, Republic of Korea, and Dr. Amitabh Mishra, University of Cincinnati. In this session, we have Dr. N. Kumar Swamy sir from ISBM University as session chair. After that, conference is scheduled in 2 parallel sessions for smooth conductions in academic conference hall as well as DBMS lab. In parallel technical session, we have Dr. Harsh Pandey and Dr. Bhumika Das as session chair in academic conference hall with plenary talk by Dr. Manoj Kumar Gupta, scientist, ANPRI Bhopal, and Dr. KVR Murthy, president LSI. We also have invited talk by Dr. Badrinath Rath, Volga University, Ethiopia, followed by invited talk by Dr. R.S.P. Mishra sir, Principal Government Polytechnic College, Ramanujganj. In parallel session on DBMS lab, we have session chair Dr. N. Kumar Swamy with invited talk by Dr. Anand Mishra, IIT Jodhpur. In this session, we have oral presentations of Computer Science and Electronics and Telecommunication Department. Technical session 2 of day 1 is chaired by Dr. Neha Dubey ma'am. This technical session is enlightened by the invited talk of Dr. Santosh Kumar sir, VIT Durg, Dr. Sadhna Agrawal from NIT Raipur, and invited talk by Dr. Martha Michalka Domanicka, MIT Poland. This session is backed by the number of oral presentations by eminent academicians, research scholars of chemistry and physics department. In parallel sessions on DBMS lab, we have session chair Dr. Ajay Kushwaha and Dr. R.M. Poddar. In this session, we have oral presentations of Computer Science Department and Electronics and Telecommunication Department. Technical session 3, that is held in 30th of April, that is today, was started sharp at 9 a.m. with the invited talk by Dr. Dhananjay Kumar Deshmukh, Vikram Sarabhai Space Center, Thiruvananthapuram. Dr. Ankush Vij, UPES, Dehradun, and Dr. Subrata Das, CSIR, NIST. Also, Dr. Balakrishna Mehta from IIT Bhilai joined us for invited talk in this session. This session was chaired by Dr. Mukesh Thakur. Panel session on DPMS lab was chaired by Dr. Manoranjan Kumar. Invited talk by Dr. K. Sadashivam Kongu with numerous oral presentations of EG&T and Civil Department. Technical session 4 chaired by Dr. Durga Sharma with invited talk by Dr. Pradeep Kumar, Dr. Shalu Atri, followed by oral presentation by Anishwar Thakur from Himachal Pradesh and number of oral presentations of EEE department. Parallel sessions on DBMS lab was chaired by Dr. Mukesh Thakur with numerous oral presentations and mechanical department. Technical session 5 was chaired by Dr. Prasanna Sharma sir from Amity University, Raipur. In this session, we have invited talk by Dr. Latif from Belgium and Dr. Latif from Belgium with oral presentations of chemistry and English department and also from physics department. Parallel sessions on DBMS lab was chaired by Dr. Anil Kumar with invited talk by Dr. Manoranjan Kumar and by Dr. Manoj Kumar Chandi. Numerous oral presentations of CSE department and mathematics departments. So, in these 2 days of conference, we have total number of oral presentations, that is 181 by all of the departments from BIT Raipur. I am truly satisfied that our guests, keynote speakers, research fellows, and students were able to experience so many different examples of clean technology and sustainable engineering solutions that could inspire them to scale up their own best models and search for applicable and commercial valuable green industrial practices. So with these words, I conclude today's international conference. Thank you all. Thank you very much. Over to you, Pooja ma'am.
Congratulations to all.
Thank you, sir. Thank you very much.
Congratulations.
Thank you, sir.
Many congratulations to the organizing committee. Thank you, ma'am.
Thank you, sir. Thank you, Prasanna, sir. Over to Pooja ma'am.
Very good afternoon to all the dignitaries, my colleagues, and all the participants. First of all, I, Jaideep Devangan, on the behalf of BIT Raipur, would like to thank management of BIT Raipur for providing us this platform to conduct a 2 days third international conference on recent trends in renewable energy and sustainable development 2022 in our Raipur campus. I would also like to thank Director Dr. T. Ramarao sir for his continuous support in the conference. I would like to give special thanks to Principal Dr. Anup Misra sir for his guidance and overall support for this successful conduction of the conference. I would like to convey my gratitude towards the convener Dr. Vikas Dubey sir, Dr. Khwaja Mohiddin sir, who work hard and give their extra effort for smooth functioning of this event. I would also like to thank all the members of steering committee and advisory committee. Without them, we would not have completed this event successfully. I would also heartily thank all the departmental heads who had shown their contribution as convener, all the co-conveners, organizing secretary who have given their 100% effort from day one to completion of this event successfully. We are highly privileged all our session chairs and keynote speaker for giving us to their valuable time and sharing their in-depth knowledge in various research fields. I would also like to thank IT cell, media cell, and various committee who lead this event to fly far Without their support, this online mode of conference would not have been possible. Last but not the least, I would like to special thank all the members of Research and Development Cell, Dr. Silpa Sharma ma'am, Neha Sharma ma'am, Preeti Pandey ma'am, Sasikant Mishra sir, Hemant Verma sir, Anand Babu sir, Abhilash sir, who led this event from behind, and without their effort, this event would not be so successful. I would also like to thank Dr. Subhra Tiwari ma'am, Ravi Shankar Panikar sir, Professor Pooja Agnihotri ma'am for smooth conduction of the event. Lastly, I would like to thank our supporting staff and housekeeping staff for their indirect continuous support. Thank you everyone.
Thank you, Jaideep sir. You too.